Imagine discovering secret civilization Earth that completely changes everything we thought we knew about secret civilization theory. What you're about to see will keep you up tonight. For decades, historians believed common assumption, but hidden in ancient records are details that don't make sense, technical knowledge they shouldn't have, precision that rivals modern technology. Recent discoveries about secret civilization Earth revealed specific, shocking detail. They knew about things we only discovered centuries later. They built structures engineers can't explain. Tonight, I'll show you exactly what they found. I'm covering 15 discoveries about secret civilization theory that will challenge everything you learned in school. Number 11 changed how I see ancient civilizations forever. Let's start with the most shocking one. Picture yourself descending through blue water off the coast of Japan. The sunlight filters down in shafts, growing dimmer with each meter. Your breathing is the only sound, slow, rhythmic, the regulator hissing softly. And then, emerging from the shadows below, you see it. Geometry, perfect right angles, flat surfaces, terraces that step down like an ancient pyramid. Stone cut so precisely it looks almost manufactured. This is Yonaguni, and it shouldn't exist. The stones form structures that span hundreds of feet, perfectly aligned, carved with what appear to be roads, channels, even stairways. If this is the work of nature, it's the most organized erosion pattern ever found. If this is the work of humans, it was built at least 10,000 years ago, when the sea level was lower, before the site was flooded. 5,000 years before the pyramids. 7,000 years before Stonehenge. Before we thought humans were capable of anything more sophisticated than hunting and gathering. The scientific community remains divided. Natural formation, they say. Curious tectonic coincidence. But the diver sees what the textbooks don't show. The precision, the intentionality, the wrongness of finding this here, now, impossibly old. What if this isn't an anomaly? What if this is a clue? What if everything we learned about the timeline of human civilization, the neat progression from primitive to advanced, from Stone Age to Bronze Age to Iron Age, is missing something? Missing thousands of years? Missing entire civilizations that rose and fell before recorded history even began. Yonaguni is just the beginning. There are structures all over the world that whisper the same impossible story. And tonight, in the quiet hours, we're going to explore them together. Let these thoughts drift as we descend into the mystery of the impossible structures, the ones that shouldn't exist, but do. The year is 1994. A Turkish shepherd named Savak Yildiz is walking across a barren hilltop in southeastern Turkey. The landscape is empty, dusty. Nothing much grows here, nothing much happens here. Just stones scattered across the ground like ancient bones. He notices something protruding from the dirt. Not a natural rock. Something shaped. Carved. He mentions it to someone. Someone mentions it to someone else. Eventually, an archaeologist named Klaus Schmidt hears about it and decides to investigate. What he finds changes everything. Göbekli Tepe. The name means potbelly hill in Turkish, an unremarkable name for what might be the most remarkable archaeological site ever discovered. Because when Schmidt starts excavating, when he starts brushing away the dirt that has accumulated over millennia, he uncovers something that shouldn't exist. Not here, not this old, not built by people who weren't supposed to know how to build anything. Massive T-shaped stone pillars, some standing nearly 20 feet tall, weighing up to 10 tons each, arranged in circular formations like ancient meeting halls or temples. The stones are carved with intricate reliefs, animals, symbols, foxes, lions, scorpions, vultures, snakes. The artistry is sophisticated, detailed. This isn't crude scratching, this is skilled stonework, and it's 11,600 years old. Let that sink in for a moment. 11,600 years? That dates to approximately 9,600 BC. This makes Göbekli Tepe older than agriculture, older than pottery, older than the wheel. According to conventional archaeology, the people who built this were hunter-gatherers, nomadic groups who supposedly lack the organization, the technology, and the motivation to construct monumental architecture. Yet here it stands. Schmidt himself said it best. Göbekli Tepe is like finding a Boeing 747 in King Tut's tomb. It doesn't fit. It shouldn't exist at this point in the timeline, but it does. The structures at Göbekli Tepe required planning. They required organization. They required hundreds, maybe thousands of workers coordinating over extended periods. They required the ability to quarry massive stones, transport them from distant locations, carve them with precision, and erect them in carefully designed patterns. And they required a reason, a purpose significant enough to mobilize that kind of effort when, supposedly, these people were focused on day-to-day survival. Hunting, gathering, finding the next meal. Why build this? We don't know. The site has no evidence of habitation, no remains of houses or cooking fires or domestic debris. It wasn't a settlement, it was something else, something ceremonial, something sacred. Something important enough to justify an effort that would be impressive even today. Now, here's where it gets interesting. Göbekli Tepe isn't alone. Travel southwest from Turkey, across thousands of miles of ocean, across the Atlantic, across Central America, and you arrive in the highlands of Bolivia. At 12,800 feet above sea level, in the thin air of the Andes, there's a place called Puma Punku, part of the larger Tiwanaku complex, and like Göbekli Tepe, it presents a problem. The stones at Puma Punku are cut from andesite and granite, hard stones, very hard. Granite ranks 6 to 7 on the Mohs hardness scale. Andesite is similar. To shape these stones, you need tools harder than the stone itself. You need advanced cutting implements, preferably metal, steel, diamond-tipped saws. The people who built Puma Punku didn't have those things. According to the historical record, they had copper and bronze tools at best, soft metals, not capable of cutting granite with precision. Yet the stones at Puma Punku are cut with laser-like precision. Picture yourself running your hand along one of these blocks. The surface is smooth, perfectly flat, the edges are sharp, forming 90-degree angles so exact you could calibrate modern tools against them. Some blocks have intricate interlocking shapes, like massive three-dimensional puzzles, H-shaped blocks. Blocks with precise channels and grooves. Blocks that fit together so tightly you can't slide a piece of paper between them. Engineers have examined these stones, modern engineers with degrees and experience in stone cutting and construction, and they're baffled. The precision would be challenging to achieve today with computer-guided equipment. To achieve it with primitive tools with copper chisels and stone hammers should be impossible. But there it is, sitting in the Bolivian highlands. Silent. Precise. Impossible. The mainstream dating places Pumapunku at around 536 to 600 AD. Not as old as Göbekli Tepe, but still ancient, still created by people who supposedly lacked the technology for this kind of work. And some researchers suggest it might be far older based on geological evidence and astronomical alignments. The precision problem doesn't end there. Let's travel east again, back across the ocean, to the coast of Japan, to the underwater structure we started with, Yonaguni. Discovered in 1987 by a dive tour operator named Kihachiro Aratake, the Yonaguni monument sits 75 feet below the surface of the Pacific Ocean. The formation is massive, over 500 feet long and 130 feet wide. It features flat surfaces, right angles, and what appear to be carved steps, columns, and terraces. Geologist Robert Schoch examined the site. He concluded that while the structure is primarily natural, some features may show signs of human modification. Other researchers, including marine geologist Masaki Kimura, argue that the monument is entirely artificial, man-made, carved intentionally. If it's man-made, it's at least 10,000 years old. That's when sea levels were low enough for the site to be above water, accessible to human builders. 10,000 years ago, before metallurgy, before writing, before civilization as we define it. The debate continues. Natural or artificial, accident or intention. But if you dive down and look at it yourself, if you run your hand along those edges, you might find yourself wondering. Nature is powerful. Nature creates wonders. But nature doesn't usually create parallel lines, right angles, symmetrical terraces. Maybe it's natural. Maybe we're seeing patterns where none exist. But maybe. Maybe we're looking at something older than we're ready to accept. Now, let's go west, to Lebanon, to a place called Baalbek. Baalbek is famous for its Roman temples, massive structures built during the height of the Roman Empire. Temples to Jupiter, Bacchus, and Venus, architectural masterpieces. But beneath those Roman structures, predating them, serve as their foundation are stones that make the Roman work look almost quaint by comparison. The trilithon. 3 stones, each weighing approximately 800 tons. 800 tons. That's one. 6 million pounds per stone. These stones form part of the foundation of the Temple of Jupiter. They sit side by side, fitted together with such precision that you can barely see the seams. The Romans didn't build this foundation, they built on top of it, which means the trilithon predates the Romans, by how much we don't know. The Romans themselves seem to regard these stones with awe, attributing their construction to gods or giants. To move an 800-ton stone today, we'd need specialized equipment, heavy-duty cranes, hydraulic systems, precisely engineered transport vehicles. And even then, it would be a monumental challenge. Moving these stones from the quarry, located about a half-mile away, would require careful planning, significant resources, and modern technology. How was it done thousands of years ago? We don't know. There are theories, lots of theories. Maybe they used rollers, logs placed under the stones, allowing them to roll across the ground. But 800 tons would crush most logs. Maybe they used ramps. Slope pathways allowing workers to drag the stones upward. but the engineering required to build a ramp strong enough at the right angle, covering half a mile. It's staggering. Maybe they used manpower. Thousands of workers pulling in coordinated effort. The math suggests you'd need at least 40,000 people pulling simultaneously to move one stone. 40,000 people in a coordinated effort, without modern communication systems, without cranes or winches or mechanical assistance. It strains belief, yet there the stones sit, precisely fitted, perfectly aligned, part of a foundation that has lasted thousands of years. Modern engineers look at Baalbek and shake their heads. It's not that it's impossible, it's that it's improbable. Wildly improbable, given the tools and techniques we believe were available at the time. Let's bring this full circle. Let's talk about what all of these sites have in common. First, they exist. They're real. You can visit them, you can touch the stones, you can measure the precision. These aren't myths or legends. They're physical evidence sitting in plain sight. Second, they're old. Older than conventional history comfortably accommodates. Göbekli Tepe predates the supposed invention of agriculture. Yonaguni, if man-made, predates writing. Baalbek's foundation predates the Roman Empire by an unknown span. Third, they demonstrate sophistication, not primitive attempts at construction, but advanced understanding of engineering, astronomy, and geometry. The builders knew what they were doing. They had knowledge. They had skills. They had purpose. And fourth, and this is perhaps the most troubling aspect, they're barely mentioned in standard education. Ask a history student about the pyramids of Egypt, they'll know. Ask about Stonehenge, they'll know. Ask about Göbekli Tepe or Puma Punku or the Baalbek Triathlon, and most will draw a blank. Why? Part of it is academic inertia. History is written in books. Books take years to revise. Curriculums are slow to change. New discoveries challenge established narratives, and institutions resist challenges. Part of it is the discomfort these sites create. They don't fit neatly into the timeline. They raise questions we don't have answers for, and academia prefers answers. Clean explanations, comfortable narratives, but the stones don't care what makes us comfortable. They sit, they endure, they wait. Göbekli Tepe waits on its Turkish hillside, its pillars carved with animals and symbols we still don't fully understand. Puma Punku waits in the Bolivian highlands, its precision blocks scattered like pieces of an incomplete puzzle. Yonaguni waits beneath Pacific waves, its terraces and right angles defying easy explanation. Baalbek waits in Lebanon, its impossible foundation supporting Roman temples built by people who had no idea how the foundation got there. These are the impossible structures, the ones that challenge our assumptions, the ones that whisper a secret about human capability, about human history, about how long we've been more than we think we were. Because if these structures are evidence of advanced knowledge existing thousands of years before we thought it possible, then the story we tell ourselves about human progress, the neat arc from primitive to modern, is incomplete. There's a missing chapter. Maybe several missing chapters. Civilizations that rose before the ones we study. Cultures that achieved sophistication before the Sumerians wrote their first cuneiform tablet. People who looked at the stars, understood geometry, moved mountains of stone, and then vanished, faded, leaving behind only these monuments, these whispers in stone, and the whisper says, "We were here." We knew things. We built things. Don't forget. But we did forget. Or maybe we never knew. Maybe the forgetting happened so long ago that by the time recorded history began, the memory was already gone, lost. Buried under time and catastrophe and the relentless march of centuries. The stones remember though, they're patient, they can wait. Tonight, as you drift towards sleep, let these images settle in your mind. The T-shaped pillars of Göbekli Tepe, rising from ancient earth, the precision cut andesite of Pumapunku, gleaming in thin mountain air, the underwater terraces of Yonaguni bathed in filtered blue light, the megalithic trilithon of Baalbek, each stone heavier than a loaded 747 aircraft. These aren't fantasies. These aren't ancient alien theories or wild speculation. These are stones, real stones, cut by someone, moved by someone, placed by someone who knew exactly what they were doing. The question isn't whether these structures exist. They do. The question is who built them, and what else did those builders know? But the stones are only the beginning. What they built is extraordinary. What they knew is even more extraordinary, because while they were moving mountains, they were also watching the sky, tracking the stars, mapping celestial patterns with a precision that would make modern astronomers pause. And that knowledge, that astronomical understanding, tells an even deeper story. Let these thoughts drift. The stones will keep watch. They've been doing it for millennia. They can do it one more night. Imagine standing in a field on a clear night, far from city lights, no street lamps, no glow from buildings on the horizon, just darkness. And above you the sky explodes with stars, thousands of them, millions of them. The Milky Way stretching overhead like a river of light. This is what the night sky looked like to ancient peoples every night. Not a rare treat glimpsed during camping trips, but the normal backdrop of existence. They lived under these stars, worked under them, navigated by them, and more than that, they studied them, tracked them, understood them, with a sophistication that should be impossible for people without telescopes, without computers, without even basic optical instruments. Yet the evidence is undeniable. Ancient civilizations possessed astronomical knowledge that rivals and sometimes exceeds what we thought they were capable of understanding. Let's start with something small. Something you could hold in your hand if you were allowed to touch it, the Antarctica mechanism. In 1901, sponge divers working off the Greek island of Antarctica discovered a Roman shipwreck. The ship had gone down around 60 BC, carrying bronze statues, pottery, and luxury goods. Among the artifacts, covered in coral and barely recognizable, was a corroded lump of bronze, something with gears. Someone almost threw it away. But an archaeologist noticed Greek inscriptions on its surface and decided to preserve it. For decades, nobody knew what it was. A piece of clockwork, clearly. But what kind? What was it for? Then, in the 1970s, researchers began using X-ray imaging to peer inside the mechanism. What they found shocked them. The Antikythera mechanism is an analog computer built around 100 BC, give or take a few decades. It contains at least 30 bronze gears, possibly more that have been lost to corrosion and time. These gears are precisely cut with triangular teeth designed to mesh smoothly and transfer motion with minimal friction. the craftsmanship rivals 18th century clockwork. And its purpose, to predict astronomical positions. The mechanism could calculate the positions of the sun, moon, and planets. It could predict eclipses. It could track the Metonic cycle, the 19-year pattern after which lunar phases repeat on the same dates. It could even account for the elliptical orbit of the moon, adjusting for its varying speed across the sky. This is not simple observation. This is mathematical modelling. This is mechanical computation of celestial mechanics. The ancient Greeks, we're told, had a philosophical understanding of the cosmos. They watched the stars. They created myths about constellations. But this is engineering. This is applied mathematics at a level we didn't think existed until medieval Europe started building cathedral clocks 1,000 years later. Who built it, we don't know for certain. Maybe Archimedes. Maybe one of his students. Maybe someone whose name has been lost to time. But here's the question that keeps astronomers up at night. To build this device, you need data. Centuries of data. You need precise observations of planetary positions, lunar cycles, solar movements. You need to notice patterns that take decades to complete. You need generational continuity, knowledge passed down from observer to observer, refined and improved over lifetimes. The Antarctica mechanism isn't just a device, it's evidence of a scientific tradition, a tradition of systematic observation and mathematical sophistication stretching back far earlier than the device itself. Now, let's go older, much older. Travel south from Greece, across the Mediterranean, to the southern edge of Egypt, near the border with Sudan. In the Nubian desert, there's a place called Nabta Playa. 7,000 years ago, this wasn't desert, it was a lake bed. Seasonal rains filled it with water, creating grazing land for cattle. People lived here, herders, nomads, according to conventional archaeology, simple pastoralists. But in the 1970s, archaeologists discovered something unexpected. A stone circle. Not as famous as Stonehenge, but potentially older, much older. The stones at Nabta Playa are arranged in alignments. They mark the cardinal directions, north, south, east, west. They align to the summer solstice sunrise, and more remarkably, they appear to form a star map. The positions of the stones correspond to the positions of stars in the constellation Orion, as they appeared around 4,800 BC. But wait, it gets stranger. Some researchers, including astrophysicist Thomas Brophy, have analysed the alignments and suggested that the stone circle incorporates knowledge of precession. Precession is the slow wobble of Earth's axis. Like a spinning top that wobbles as it spins, Earth's rotational axis traces a circle in space. This cycle takes approximately 26,000 years to complete. Because of precession, the stars appear to drift slowly over centuries. The North Star won't always be Polaris. In 12,000 years, Vega will be the North Star. Ancient peoples who track the stars across generations would have noticed this drift. But to calculate the full cycle, to understand that the pattern repeats every 26,000 years, that requires mathematical sophistication, that requires record keeping across millennia, that requires a scientific culture dedicated to observation and analysis. And Nabta Playa is 7,000 years old, predating Stonehenge by over 1,000 years, built by people who supposedly had no writing system, no formal mathematics, no institutional science, yet there it stands, aligned, precise. Knowing, Let's jump continents to Central America, to the Maya. The Maya are famous for their pyramids, their writing system, their cities carved from the jungle. But their most impressive achievement might be their calendar. The Maya tracked time with obsessive precision. They had multiple interlocking calendars, the Tzolkin, a 260-day ritual calendar, the Harb, a 365-day solar calendar, and the Long Count, which tracked much larger cycles of time. But here's what's extraordinary. The Maya didn't just track the sun, they tracked Venus. Venus is the third brightest object in the sky after the sun and moon. It appears as the morning star or evening star, depending on its position relative to Earth and the sun. Its cycle from evening star to morning star and back takes 584 days on average. The Maya calculated this cycle, and not approximately, they calculated it to within minutes of the modern value. Modern astronomers using telescopes and computers have determined that Venus's synodic period is 583, 92 days. The Maya, using naked eye observation over centuries, calculated 583, 92 days. Exactly. Think about what that requires. You need to observe Venus over multiple cycles. You need to record when it appears, when it disappears, when it reaches maximum brightness. You need to correlate these observations with your calendar system. You need to average out variations, you need mathematics, precision, patience, and you need to care. You need to consider this important enough to dedicate resources, time, and intellectual effort across generations. Why? Why track Venus with such precision? We don't fully know. The Maya associated Venus with war and considered its appearances to be omens. But that doesn't fully explain the mathematical sophistication. Omens don't require calculations accurate to decimal points. Perhaps there's something deeper. Some knowledge we've lost. Some reason that tracking celestial mechanics mattered to them in ways we no longer understand. Now let's talk about something that shouldn't be possible. The Dogon people of Mali, West Africa, have an oral tradition, stories passed down through generations, stories about the cosmos, about the stars, and specifically about the star Sirius. Sirius is the brightest star in the night sky. Easy to spot, important in many ancient cultures. The Egyptians used its Heliocut rising, its first appearance in the dawn sky after being hidden by the sun, to predict the flooding of the Nile. But the Dogon don't just know about Sirius. They know about Sirius B. Sirius B is a white dwarf star orbiting Sirius A. It's incredibly dense. A teaspoon of its material would weigh several tons on Earth. It completes one orbit around Sirius A every 50 years. And here's the critical detail. Sirius B is invisible to the naked eye. You need a telescope to see it, a good telescope. Sirius B wasn't discovered by Western astronomy until 1862, when American telescope maker Alvan Graham Clark spotted it. Its existence had been predicted mathematically in 1844 because astronomers noticed that Sirius A wobbled slightly, suggesting an unseen companion. But the Dogon knew about it. According to their oral tradition, they knew about the companion star. They knew about its 50-year orbit. They knew it was incredibly dense. They called it Potolo, the tiny seed star. How? The mainstream explanation is that they learned about it from Western visitors in the early 20th century and incorporated it into their mythology. That's possible. Contact between cultures can transmit knowledge in unexpected ways. but the Dogon claim their knowledge is ancient, passed down for centuries, taught to them by visitors called the Nommo, who came from the Sirius system long ago. We don't have to believe in ancient astronauts to find this troubling, because even if they learned it recently, the fact remains, advanced astronomical knowledge has a way of showing up in unexpected places, in oral traditions, in myths, in cultures that supposedly had no access to telescopes or mathematical astronomy. It keeps happening. Let's go to Ireland. To a place called Newgrange. Newgrange is older than you think, older than the pyramids, older than Stonehenge. It was built around 3200 BC, over 5,000 years ago. It's a passage tomb, a massive mound of earth and stone with a narrow passageway leading to a central chamber. And once a year, on the winter solstice, something extraordinary happens. As the sun rises on the shortest day of the year, a shaft of light enters through a small opening above the entrance. This light travels down the 60-foot passageway, illuminating the inner chamber for exactly 17 minutes. Then it fades. The chamber returns to darkness. This isn't an accident. The entire structure was designed for this moment. The angle of the passageway, the height of the opening, the orientation of the mound. Everything calculated to capture that single sunrise. That single moment when the sun begins its journey back towards summer. To build this, you need to know exactly where the sun will rise on the winter solstice. You need to understand the solar year. You need geometry. You need engineering. You need to care enough about the solstice to build a monument that will capture its light for millennia. 5,000 years later, it still works. The light still enters, still illuminates, still marks the turning of the year. The people who built Newgrange didn't write books. They left no mathematical treatises. They left no astronomical tables. But they understood the sky. They tracked the sun. They built in stone a calendar that still functions. Now let's go east. To Southeast Asia, to Cambodia, Angkor Wat is famous. A massive temple complex, Hindu, later Buddhist, built in the early 12th century AD. Much more recent than Newgrange or Göbekli Tepe, but still extraordinary. Because Angkor Wat isn't just a temple, it's a map, a star map. Researchers analysing the layout of the temple have noticed something remarkable. The positions of the towers and structures correspond to the constellation Draco, not as Draco appears today. As Draco appeared around 10,500 BC. Wait, the temple was built in the 12th century AD. Why would it map the stars as they appeared 12,000 years earlier? Precession, that slow wobble of Earth's axis. The stars changed position over millennia. If the builders of Angkor Wat had ancient star charts, maps showing the sky as it appeared thousands of years earlier, and if they considered those charts sacred or significant, they might have incorporated them into the temple's design. But where would they get ancient star charts? The same place the Egyptians might have gotten them when they built the pyramids of Giza. The same place the builders of Nabta Playa might have gotten the knowledge to map Orion from an older source. A source that watched the stars when they were in different positions, a source that knew about precession, that tracked the long cycles, that preserved the knowledge through catastrophe and time. We're seeing patterns now, patterns across cultures, across continents, across millennia. the Greeks building mechanical computers to track celestial cycles, the Nubians aligning stones to stars and solstices, the Maya calculating planetary orbits to decimal precision, the Irish marking the winter solstice with architectural light, the Cambodians encoding ancient star maps into temple layouts. These aren't isolated achievements, they're expressions of the same thing, the same impulse, the same knowledge. The knowledge that the sky matters, that the patterns matter, that tracking the stars, understanding the cycles, preserving the data across generations, these things are important, critical even. But why? Why does it matter so much? For navigation, sure. Sailors used stars to find their way. Farmers use the sun and moon to know when to plant and harvest. Practical reasons. But the precision goes beyond practical. You don't need to calculate Venus's orbit to within minutes to know when to plant corn. You don't need to understand precession to navigate by the North Star. This knowledge suggests something else, something deeper. Maybe they were tracking something. Some cycle, some pattern in the cosmos that mattered to them in ways we've forgotten. Maybe the astronomical alignments in their monuments weren't just decorative or religious. Maybe they were preserving data, encoding information in stone. Information that could survive even if the culture didn't. The stars are eternal, or near enough. They move, yes, but predictably. If you want to preserve information for thousands of years, writing it in star maps isn't a bad strategy. Stars outlast paper, outlast language, outlast civilizations. And if you build monuments aligned to those stars, monuments massive enough to survive catastrophe, you create a backup, a physical reminder, a message that endures. But a message about what? Perhaps about what they saw coming, what they watched approaching in the celestial patterns, what they survived once and wanted to warn us about. They watched the stars, but they also watched the earth. And what they saw coming changed everything. The sky holds patterns, but the earth holds scars. And those scars tell a story of catastrophe, of floods, of fire, of a world transformed in an instant. Let these thoughts drift. Picture those ancient astronomers standing beneath Orion, beneath Sirius, beneath Venus blazing in the twilight. They tracked, they calculated, they preserved, and they tried to tell us something. The stars will keep turning. The cycles will continue. And somewhere in those patterns, in those ancient alignments, the message waits. Good night, astronomers. Your knowledge endures. There's a story that nearly every culture on Earth tells. A story about water, about rising seas, about the world drowning, about survival against impossible odds. The details vary, the names change. The gods responsible differ from culture to culture, but the core narrative remains remarkably consistent. There was a world before this one. That world was destroyed by water. A few people survived. We are their descendants. This is the flood myth, and it's not a myth, not in the sense we usually mean. It's a memory. Let's start with the one you probably know, the biblical flood. Noah, the ark, 40 days and 40 nights of rain. God cleansing the earth, 2 of every animal. The dove returning with an olive branch, the rainbow as a promise. It's a powerful story, deeply embedded in Western culture, but it's not unique, not even close. The Sumerians told a flood story thousands of years before the biblical account was written. In their version, a man named Utnapishtim is warned by the god Ea that the other gods plan to destroy humanity with a flood. Ea tells him to build a boat, to seal it with pitch. To bring his family, craftsmen, and animals, the flood comes, the boat survives. Utnapishtim releases a dove, then a swallow, then a raven. The raven doesn't return, indicating land has emerged. Sound familiar? The biblical flood narrative appears to be adapted from this older Sumerian story, which itself appears in the Epic of Gilgamesh, one of the oldest written works we have. But even the Sumerian version wasn't the first. It was already ancient when it was written down around 2100 BC. Now let's go east to India. The Matsya Purana tells of Manu, the first man who is warned by a fish that a great flood is coming. The fish tells Manu to build a boat and fill it with seeds and animals. The flood arrives. Manu ties his boat to the fish, which grows enormous and tows the boat to safety in the mountains. Go to China. The Great Flood is central to Chinese mythology. The hero Yu tames the floodwaters through engineering and hard work, creating channels to drain the land. His success is so significant that he becomes emperor, founding the Xia dynasty. Go to Greece. Deucalion and Pyrrha survive a flood sent by Zeus to destroy humanity. They build a chest, float for 9 days, and land on Mount Parnassus. They repopulate the earth by throwing stones over their shoulders, which become people. Go to Australia. The Aboriginal peoples have stories of floods that drown the land. The Bundaberg tells of Gajara, a giant serpent who caused massive flooding. The Gunwingu people remember when the sea level rose and swallowed coastal areas. Go to the Americas. The Hopi tell of 3 previous worlds destroyed by catastrophe, including one destroyed by flood. The Aztecs speak of the world being destroyed and recreated multiple times, with one cycle ending in flood. The Inca have flood stories, so do the Cherokee, so do the Lakota, so do indigenous peoples throughout North, Central, and South America. Over 270 cultures worldwide have flood myths. That's not an exaggeration. Researchers have catalogued them, analysed them, compared them. And the similarities are stunning. Almost all describe a catastrophic flood covering the earth or most of it, divine or supernatural cause. A few survivors warned in advance. Survival via boat or raft, animals saved along with humans, landing on a mountain or high ground, repopulation of the earth from survivors. These aren't vague similarities. These are specific narrative parallels appearing in cultures separated by thousands of miles with no known contact. Coincidence? Maybe. Humans live near water, rivers flood, coasts flood, tsunamis happen. Maybe every culture independently developed flood stories based on local catastrophes. But there's a problem with that explanation. The myths don't describe local floods. They describe global or near global events, water covering the whole world. Drowning everything, destroying civilization. This isn't a river overflowing its banks. This is something planetary. And here's where it gets interesting, because geology backs them up. Around 11,600 years ago, something happened. Something dramatic. The planet was emerging from the last ice age. Massive ice sheets covered much of North America, Europe, and Asia. Then, suddenly, the climate shifted. The Younger Dryas period, a temporary return to glacial conditions, ended abruptly. Within decades, possibly within years, global temperatures rose. The ice sheets began melting, fast. When ice melts, the water has to go somewhere. It goes into the oceans. And when continental ice sheets melt, ice sheets thousands of feet thick, covering millions of square miles, the sea level rises significantly. Geologists call one of these events meltwater pulse 1b. It occurred around 11,300 years ago. Sea levels rose approximately 15 feet in less than 500 years. That might not sound dramatic until you consider what it means for coastal populations. 15 feet of sea level rise drowns coastlines, swallows harbours, inundates river deltas, destroys settlements built near the water, which is where most settlements were built because water means food, transportation, and trade. But 15 feet is actually conservative. Over the course of the post-glacial melt, from roughly 18,000 years ago to 8,000 years ago, sea levels rose approximately 400 feet. 400 feet. The coastlines we know today didn't exist. The world map was different. Picture this. During the last ice age, so much water was locked up in ice that the ocean levels were hundreds of feet lower. Land that's now underwater was above sea level, habitable, productive. People could have lived there, built there, thrived there. Then the ice melted, the water rose, and everything on those low-lying coasts was drowned. Let's look at specific examples. Sunderland, ever heard of it? Probably not. It doesn't exist anymore. Sunderland was a massive landmass connecting what are now the islands of Indonesia, Malaysia, and Southeast Asia. During the Ice Age, when sea levels were lower, this entire region was above water. It was roughly the size of modern-day India, a subcontinent, a vast tropical land with rivers, forests, and coastlines. And it was habitable, perfect climate, rich resources. If humans lived anywhere in Southeast Asia during the Ice Age, they lived in Sunderland. Then the ice melted, the sea level rose, and Sunderland drowned. What was once a continuous landmass became scattered islands, Indonesia, the Philippines, Malaysia, Borneo, Sumatra, Java. These aren't separate islands that happen to cluster together. They're the mountain peaks of a drowned continent. If there were cities on Sunderland, if there were settlements, ports, centres of culture, they're now under 200 feet of water. Beneath the Java Sea, the South China Sea, gone. Inaccessible without submarines and sophisticated underwater archaeology. Could there have been an advanced civilization on Sunderland? We don't know. We can't look. The evidence is submerged. Now go west to Europe. Doggerland. Another name you probably haven't heard. Another drowned land. Doggerland connected Britain to continental Europe. During the Ice Age, you could walk from England to France to Belgium to the Netherlands to Germany. No English Channel, no North Sea, just rolling plains, hills, and river valleys, and people live there. We know this because fishermen occasionally dredge up artifacts from the North Sea, stone tools, animal bones, evidence of human habitation. The North Sea is a graveyard. A drowned landscape that was once home. Around 6,200 BC, a catastrophic event called the Storegga Slide occurred. A massive underwater landslide off the coast of Norway triggered a tsunami. The tsunami swept across Doggerland, which was already being slowly submerged by rising sea levels. The wave may have been the final blow. Within a relatively short time, Doggerland was completely underwater. The survivors, if there were survivors, would have fled to higher ground, to what became the British Isles, to what remained of coastal Europe, and they would have carried with them memories, stories, Stories about the land that drowned, about the wave that came, about the world that was lost. Now go to the Middle East, to the Persian Gulf. The Persian Gulf is relatively shallow. During the Ice Age, when sea levels were lower, much of it was dry land. The Tigris and Euphrates rivers, the rivers that later cradled Sumerian civilization, flowed through a valley that is now underwater. That valley was fertile, well watered. An ideal place for early settlements. Then the sea level rose, the gulf filled, the valley drowned. If there were settlements there, if there were early agricultural communities, early experiments with civilization, they're now beneath the Persian Gulf. Some researchers have suggested that the biblical Garden of Eden might be a memory of this fertile valley. A paradise lost when the waters came, a story passed down through generations until it became myth. Go to India, off the western coast of Gujarat. In 2001, marine archaeologists using sonar discovered structures underwater near the city of Dwarka. The structures appeared artificial, stone walls, geometric patterns. They conducted underwater excavations. They found artifacts, pottery, anchors, wood. They carbon dated the wood, 9,500 years old. If that date is accurate, this is one of the oldest submerged settlements ever discovered. A city, or at least a significant settlement, existing thousands of years before Sumerian civilization, and it's underwater, drowned when sea levels rose. The local mythology talks about Dwarka as the city of Lord Krishna, an ancient city that sank into the sea. The myth said it was submerged. Archaeologists found it exactly where the myth said it would be. Underwater, memory preserved in story. Story confirmed by evidence. Are you noticing the pattern? All over the world, there are drowned coastlines, submerged lands, lost territories, and all over the world there are myths about floods, about drowning, about worlds that existed before the waters came. The timing matters too. Most of the dramatic sea level rise occurred between 15,000 and 8,000 years ago. The most rapid pulses happened around 14,000, 11,600 and 8,000 years ago. 11,600 years ago, that's right around when Göbekli Tepe was built, right around when Plato said Atlantis sank, right around when the Younger Dryas ended and the climate rapidly warmed. Speaking of Plato, let's talk about Atlantis. Most people think Atlantis is pure fiction, a philosophical allegory Plato invented to make a point about hubris and the fall of civilizations. And maybe it is. Plato wrote about it in two dialogues, Timaeus and Critias, around 360 BC. He describes a powerful island nation that existed beyond the Pillars of Hercules, beyond the Strait of Gibraltar in the Atlantic Ocean. According to Plato, Atlantis was advanced, prosperous, powerful. It had a sophisticated government, impressive architecture, and naval dominance, but it became corrupt, greedy. The gods punished it. In a single day and night of catastrophe, Atlantis sank beneath the waves. And here's the detail that matters. Plato says this happened 9,000 years before the time of Solon. The Athenian statesman who supposedly heard the story from Egyptian priests. Solon lived around 600 BC. 9,000 years before that is 9,600 BC. 11,600 years ago, right in the window of catastrophic sea level rise, right when Sunderland was drowning, right when Doggerland was being submerged, right when coastlines worldwide were being inundated. Coincidence? Maybe. Or maybe Plato was passing along a garbled memory, a story told by Egyptian priests who preserved it from earlier cultures who survived the flooding. A memory of a real place, not necessarily an island in the Atlantic, but somewhere that was drowned when the ice melted and the seas rose. We don't have to believe in a literal Atlantis to recognize that something real is behind these stories. Something traumatic, something that happened to enough people in enough places that the memory persisted for thousands of years. Imagine you're living on the coast 12,000 years ago. Your family has lived here for generations. You fish. You gather shellfish. You've built homes near the water. Life is good. Then, over the course of your lifetime, you notice something. The beach is smaller than it used to be. The shoreline is closer to your home. Every year, a little closer. The water is rising. Over generations, the rise accelerates. Within a few centuries, the coastal plain where your ancestors lived is gone. Villages are abandoned. People retreat inland, higher, away from the encroaching sea. And if there was a sudden event, a tsunami, a storm surge, a particularly rapid pulse of melting ice, it would be catastrophic. Sudden. Devastating, the kind of event that gets remembered. Told as a story, passed down as a warning. The waters rose, not in a single day perhaps, but fast enough to be noticeable within a human lifetime, fast enough to displace populations, fast enough to drown cities, villages, sacred sites, farmland, and the survivors would carry the memory of the flood, the memory of the world that drowned, the memory of what was lost. They would tell their children. Their children would tell their children. The details would change. The gods responsible would vary by culture, but the core truth would remain. We survived a catastrophe. The water came. The world ended, but we endured. These aren't myths in the sense of make-believe. They're myths in the sense of sacred stories, stories that preserve truth through metaphor and narrative, truth about real events that shaped human history. The geological evidence confirms it. The coastlines were different. The sea level was lower. Then it rose, dramatically, drowning vast territories. The archaeological evidence hints at it. Underwater structures off Japan, off India. Artifacts dredged from the North Sea. Evidence that people lived on lands now submerged. And the mythological evidence screams it. Over 270 cultures telling the same story. Water, drowning, survival, memory. The flood happened, not a flood. The flood. The catastrophic rising of sea levels that transformed the world map and drowned coastlines globally. And if there were civilizations on those coastlines, if there were people who had built cities, developed culture, advanced knowledge, what happened to them? Some died, obviously. Catastrophes kill, but some survived. Fled inland, moved to higher ground, adapted. And what did they bring with them? Knowledge. The knowledge we've been discussing. Astronomical knowledge. Architectural knowledge. Mathematical knowledge. Knowledge preserved through catastrophe. Knowledge passed down to the cultures that came after. The survivors became the teachers, the wise ones, the ones who remembered the old world, the ones who tried to warn about the cycles, about the patterns, about what the earth and sky could do. The coastlines vanished, the old world drowned. And with them, some things we're only now beginning to glimpse. Libraries, records, cities, ports. The accumulated knowledge of Ice Age civilizations that thrived on lands now hundreds of feet underwater. We call them primitive. We assume they were simple hunter-gatherers, scratching out survival. But what if that's wrong? What if the survivors we see in the archaeological record after the flood, the builders of Göbekli Tepe, the astronomers of Nabta Playa, what if they're the refugees, the ones carrying fragments of what was lost? Let these thoughts drift as the waters rise in your imagination. Picture Sunderland in the twilight of the Ice Age. Green, populated, thriving. Then the ice melts. The seas rise, slowly at first, then faster. Villages abandoned, people fleeing, the land shrinking year by year until only islands remain. Picture Doggerland, rolling plains where the North Sea now sits, families, communities, then the wave, the Storegga tsunami. The land drowning in a day. Picture the Persian Gulf Valley, rivers flowing through paradise, then the water coming, the gulf filling, the garden lost. The survivors carried the memory, encoded it in myth, passed it down through thousands of years, and now finally we're beginning to understand. The flood wasn't a myth, it was real. The waters rose, the coastlines vanished, and with them civilizations we're only now starting to glimpse beneath the waves. Sleep now. The waters are calm tonight, the coastlines are stable for now. But the stones remember, the myths remember. And somewhere beneath the ocean, the drowned lands wait. Picture yourself in southern Iraq. It's 3200 BC. You're standing in a city that shouldn't exist yet. Uruk, or or Eridu, one of the great Sumerian cities. The buildings rise around you. Temples, granaries, administrative centres. The streets are organised, planned. There's marketplace. Artisans work in copper and bronze. Farmers bring grain from irrigated fields. And in a temple complex, a scribe sits with a reed stylus and a clay tablet. He's writing, not drawing pictures, not making simple tally marks. He's writing in cuneiform. A sophisticated writing system with hundreds of symbols representing sounds, words, and concepts. He's recording a business transaction, the delivery of grain, the payment of taxes, the stuff of civilization. This is Sumer. The first civilization, we're told, the place where it all began, where humans first developed cities, writing, organised government, mathematics, and law. But here's the problem. It didn't develop. It appeared. There's no clear archaeological progression from simple villages to Sumerian cities. No gradual evolution from pictographs to cuneiform. No slow build-up from tribal organisation to urban civilization. The Sumerians seem to arrive on the scene already knowing how to do all of this. Already writing, already building cities, already organising complex societies with hierarchies, specialisation, trade networks, and legal codes. It's like turning on a light switch. One moment, darkness. The next, illumination. Where's the transition? Archaeologists have searched for it, for the Proto-Sumerian period, for the simple villages that should show the gradual development of civilization. And they've found some evidence of earlier settlements, yes, but nothing that adequately explains the sophistication that suddenly appears around 3200 BC. The Sumerians themselves had an explanation. They said civilization was a gift from the gods, specifically from beings called the Anunnaki, who came from the sky and taught humans the arts of civilization. They taught writing, mathematics, agriculture, metallurgy, astronomy, and governance. We dismiss this as mythology. primitive people attributing their achievements to supernatural beings. But what if there's a kernel of truth buried in the metaphor? What if the gods who taught civilization were actually survivors? Survivors of the flood. Survivors from the drowned coastlands. People who had maintained knowledge through the catastrophe and emerged into a post-flood world where most of the population had been displaced, disrupted, scattered. These survivors would have seemed godlike to the people they encountered. They knew things. How to track the stars, how to build in stone, how to organize labor, how to record information, skills that had been developed over generations on the drowned lands and now survived only in the memories of refugees. They became teachers, advisors, priest-kings, the wise ones who remembered the old world and the civilizations they influenced didn't develop gradually. They inherited knowledge. They started advanced. Let's look at Egypt. Ancient Egypt is one of the most studied civilizations in history. Thousands of books, decades of excavation, museums full of artifacts. We know a lot about Egypt, and here's something strange. The oldest Egyptian monuments are the most sophisticated. The Great Pyramid of Giza was built during the 4th dynasty around 2560 BC. It's an engineering marvel. 2 million stone blocks, some weighing 80 tons, fitted with precision, aligned to cardinal directions within fractions of a degree. The internal passageways are straight and true. The king's chamber has granite beams weighing 50 tons precisely positioned overhead. The construction tolerances are extraordinary. Blocks fitted so tightly you can't slide paper between them. The base is level to within inches over a 13-acre footprint. The pyramid encodes mathematical constants. The ratio of the perimeter to the height approximates 2p. The dimensions encode the proportions of Earth's hemisphere. Whether these mathematical relationships are intentional or coincidental is debated, but the precision isn't debatable. The Great Pyramid represents a level of engineering sophistication that's undeniable. Now, conventional Egyptology tells us that pyramid building evolved. It started with simple mastaba tombs, rectangular mud brick structures. Then came the step pyramid of Djoser, stacked mastabas forming a step structure. Then the bent pyramid at Dashur, an attempt at a smooth-sided pyramid that had to be modified mid-construction when the angle proved unstable. Then finally, the Great Pyramid, the perfected design, a logical progression, simple to complex. Trial and error, learning, except here's the problem. The pyramids built after Giza are worse, less precise, smaller, cruder construction, lower quality. The 5th and 6th dynasty pyramids are significantly inferior to the 4th dynasty pyramids. By the Middle Kingdom, pyramid construction has declined dramatically. The pyramids are smaller, made of mud brick, filled with rubble, and many have collapsed. This is backwards. Technology should improve over time. You learn from mistakes, you refine techniques, you get better. But in Egypt, pyramid technology got worse. As if the knowledge required to build the Great Pyramid was being lost, not gained. Robert Schoch, a geologist from Boston University, has proposed something even more radical. He examined the Sphinx, the massive limestone statue with the body of a lion and the head of a human sitting near the pyramids, conventional dating places. The Sphinx around 2500 BC, built by Pharaoh Khafra. But Schoch noticed something. The erosion pattern on the Sphinx doesn't match wind erosion, it matches water erosion, specifically rainfall erosion, deep vertical channels carved by water running down the limestone over long periods. But Egypt has been arid for thousands of years. The Sphinx sits in a desert. When was there enough rainfall to cause this kind of erosion? Schoch's conclusion, the Sphinx is much older than conventional Egyptology suggests, perhaps carved during a wetter period when the Sahara wasn't a desert. That wetter period ended around 10,000 BC, which would make the Sphinx at least 12,000 years old. This is controversial, highly controversial. Most Egyptologists reject it. They offer alternative explanations for the erosion: groundwater, Nile flooding, differential weathering of the limestone. But Schoch stands by his geological analysis, and if he's right, it means the Sphinx predates Egyptian civilization by thousands of years. It means there was someone in Egypt around 10,000 BC with the knowledge and organization to carve a massive monument, someone who was there before the pyramids, before the dynasties, before the civilization we call ancient Egypt. Perhaps the survivors, the ones who knew, the ones who remembered. Now let's go to Eastern Europe, to a place most people have never heard of, the Vinča culture. The Vinča culture existed in what is now Serbia and surrounding regions from approximately 700 BC to 4500 BC. They built settlements, worked in copper, made pottery, and they used symbols. These symbols appear on pottery, figurines, and other artifacts, geometric shapes, lines, curves, abstract designs. For a long time, they were dismissed as decorative, artistic flourishes. But in recent decades, researchers have taken a closer look, and some have suggested these symbols are proto-writing, an early writing system predating Sumerian cuneiform by over 1,000 years. The symbols are consistent. They appear repeatedly across different sites. They seem systematic, as if they carry meaning beyond decoration. They include signs that look like they represent concepts or sounds. If the Vinča symbols are writing, and that's still debated, then writing wasn't invented by the Sumerians. It was invented earlier, by people living in Neolithic Europe. People who supposedly had no cities, no complex government, no need for written records. Why would they develop writing? What were they recording? We don't know. The symbols haven't been deciphered. We don't know what language they represent or what they say, but the existence of systematic symbols suggests something. Suggests that knowledge transfer was happening, that information was being preserved. That even in the Neolithic period, humans recognized the value of recorded communication. Now, across the ocean, to South America, to the Inca. The Inca are famous for many things: their road system, their terraced agriculture, their stone masonry. But here's something interesting. They didn't have writing, at least not writing as we typically define it. No alphabet, no hieroglyphs, no cuneiform. But they had quipu. A quipu is a recording device made of coloured strings. A main chord with secondary chords hanging from it, knotted in specific ways. Different colours, different knot types, different positions, all encoding information. For a long time, scholars assumed quipu were just accounting tools, knots representing numbers, a way to record quantities, how much grain in the storehouse, how many llamas in the herd, how many workers on a project. But recent research suggests quipu might be more than that. They might be actual writing, a three-dimensional writing system encoding not just numbers, but narratives, histories, maybe even poetry. Different colours might represent different categories. Knot types might represent phonetic sounds. The positioning might convey syntax and grammar. If this is true, then Quipu is one of the most unique writing systems ever developed. Not scratched on clay or painted on papyrus, but knotted into string. A completely different approach to recording information, developed independently, proving that humans will find a way to preserve knowledge, even if it doesn't look like traditional writing. But here's the question. How did the Inca organize a vast empire spanning thousands of miles with millions of people without writing? How did they coordinate labor on massive construction projects? How did they maintain records and histories? Maybe Quipu is the answer. A sophisticated information system we're only beginning to understand. Or maybe they had other knowledge, oral traditions, memory techniques, ways of preserving and transmitting information that leave no archaeological trace. Now, let's talk about Mohenjo-Daro. Mohenjo-Daro is a city in what is now Pakistan, part of the Indus Valley Civilization, also called the Harappan Civilization. It dates to around 2500 BC. And when you look at it, you see something remarkable. This isn't a primitive settlement. This is urban planning. The city is laid out on a grid, streets at right angles, blocks of uniform size, a sophisticated drainage system with covered sewers running beneath the streets, public baths, multi-story buildings, standardized fired bricks. The Great Bath, a large public bathing area, is constructed with precision, waterproofed with bitumen, supplied with water from wells, drained through a complex system of channels. There's evidence of a central authority, standardized weights and measures, organized trade, seals with writing, the Indus script which remains undeciphered. And here's the thing. Mohenjo-Daro doesn't seem to evolve from simpler settlements. It appears fully formed, planned, as if the builders already knew how to design cities, already understood sanitation, already grasped the importance of organized infrastructure. Where did they learn it? Maybe from earlier cultures, maybe from survivors of the drowned coastlands who brought knowledge of urban planning, knowledge developed on Sunderland or other submerged territories and preserved through the flood. We don't know. But the pattern is there. Civilization appearing suddenly, with sophistication, with knowledge that seems inherited rather than developed. Let's talk about agriculture. The Neolithic Revolution, the transition from hunting and gathering to agriculture, is supposed to have happened gradually, over thousands of years. Different regions at different times. People slowly learning to domesticate plants and animals. But when you look at the archaeological evidence, something strange emerges. Multiple crops appear to have been domesticated nearly simultaneously across different regions with no known contact. Wheat and barley in the Fertile Crescent around 10,000 BC. Rice in China around 9,000 BC. Corn in Mexico around 9,000 BC. Squash in South America. Potatoes in the Andes, each in different regions, each requiring specific knowledge about selective breeding, planting cycles, and soil management. Why the cluster? Why did agriculture suddenly become a thing after hundreds of thousands of years of hunting and gathering? One theory is climate change. The end of the Ice Age created conditions favourable for agriculture, warmer temperatures, more stable climate, longer growing seasons. But climate doesn't teach you how to selectively breed plants. That requires knowledge, experimentation, trial and error over many generations, unless someone already knew, unless the knowledge already existed and was being applied in new regions by people fleeing the drowned coastlands, survivors bringing seeds, bringing techniques, bringing the accumulated agricultural knowledge of a lost world. Now let's talk about metallurgy. Bronze working, the alloying of copper and tin, appears in different regions at roughly similar times, around 3300 BC in the Near East, around 3000 BC in the Indus Valley, around 2000 BC in China, around 5500 BC in Southeast Asia. Creating bronze requires specific knowledge. You need to know where to find copper ore, where to find tin ore, how to extract the metal from the ore through smelting, what ratio of copper to tin produces the best alloy, how to heat the furnace to the right temperature, how to pour the molten metal into moulds. This isn't something you stumble upon by accident. This is accumulated knowledge, experimentation, failure, success, refinement. Yet bronze working appears relatively quickly once it appears at all, as if the knowledge spreads rapidly, or as if people in different regions have access to a common source of knowledge. In some locations, sophisticated bronze work appears before simpler forms, complex casting techniques before simple hammering techniques, as if the knowledge is being applied fully formed rather than developed incrementally. Again, the pattern, inheritance, not invention. Are you seeing it now? The thread connecting these examples. Sumer appearing with writing and mathematics, Egypt building its most sophisticated pyramids first, Vinca using symbols that might be proto-writing, Inca preserving information in Quipu, Mohenjo-Daro planned from the start. Agriculture appearing simultaneously across continents, bronze working spreading rapidly. These aren't isolated achievements, they're expressions of knowledge being transmitted, preserved, inherited. The survivors of the flood didn't just survive physically, they survived intellectually. They carried with them the accumulated knowledge of the drowned civilizations, the astronomical observations, the architectural techniques, the mathematics, the writing systems, the agricultural methods, the metallurgy, and they became teachers. In Sumer, they were the Anunnaki. In Egypt, they were the gods who taught Thoth, the god of wisdom. In South America, they were Viracocha, the bearded god who brought civilization. In Mesoamerica, they were Quetzalcoatl, the feathered serpent who taught writing and agriculture. Every culture has these figures, these civilizing heroes, these teachers who came from somewhere else and brought knowledge. We call them myths, but what if they're memories? Memories of real people, survivors, refugees from the drowned lands, people who knew things, who remembered the old world, who tried to preserve what was lost by teaching the next generation. They didn't just survive, they remembered, and they tried to tell us, through monuments that encode astronomical knowledge, through myths that preserve the memory of catastrophe, through sudden bursts of civilization that appear fully formed, as if the knowledge came from somewhere else. The drowned lands took much, but they didn't take everything. The survivors carried the seeds of the lost world, and they planted them in the post-flood world. Some seeds grew, some civilizations flourished. Sumer, Egypt, the Indus Valley, China, Mesoamerica. Some knowledge was preserved, writing, astronomy, architecture, agriculture, but some was lost, scattered, forgotten, buried under the weight of centuries and catastrophe. The maps that showed coastlines before the flood, maps that shouldn't exist, yet do. Let these thoughts settle as you drift toward sleep. Picture the survivors standing on the shore, watching the old world drown. They carry with them seeds, techniques, star charts, stories, knowledge. They walk inland. They find people, scattered groups struggling in the aftermath of the catastrophe. And they teach how to plant, how to build, how to track the stars, how to organize, how to remember. The students become civilizations, the teachers become legends, gods, heroes, myths, but the knowledge endures, passed down, fragmented, partial, but real. Sleep now. The inheritance continues. You're part of it. The chain of knowledge stretching back through thousands of years, from teacher to student, from survivor to descendant. The drowned lands are gone, but their legacy remains in every city, every book, every grain of wheat, every star chart. They didn't just survive, they remembered, and they tried to tell us. Good night, survivors. Your legacy endures. It's 1929. A historian named Gustav Adolf Deismann is working in the Topkapi Palace in Istanbul. The palace has been converted into a museum following the fall of the Ottoman Empire. Among the collections, swords, ceramics, royal garments, there's a library, maps, old maps, dusty, forgotten. Deismann is cataloguing them when he comes across something unusual, a map drawn on gazelle skin. The colours are faded but still visible, blue for water, green for land. The style is Ottoman from the early 16th century. The cartographer's signature is in the corner, Piri Reis, an Ottoman admiral and mapmaker. The date, 1513 AD. Deismann looks closer. The map shows the Atlantic Ocean, the western coast of Africa, the eastern coast of South America, Spain, Portugal, the Caribbean islands. Nothing too unusual for a map from 1513. European explorers had reached the Americas by then. Columbus made his first voyage in 1492. Other expeditions followed, but then Deismann notices something strange. At the bottom of the map, there's a coastline, a landmass, drawn with careful detail, mountains, rivers, bays, Antarctica. But Antarctica wasn't discovered until 1820, over 300 years after Piri Reis drew this map. And even then, what the explorers found was ice. Endless ice covering the entire continent. No one saw the actual coastline beneath the ice until the 20th century, when ice-penetrating radar and sonar mapping revealed what lay underneath. Yet here it is on the Piri Reis map. A coastline, detailed, accurate. Deismann doesn't know what to make of it. The map is filed away, studied occasionally, but it doesn't fit the narrative. So it's treated as a curiosity, an anomaly. Decades later, in 1956, a US Navy officer named Arlington Mallory studies the map more carefully. He compares it to modern surveys of Antarctica. Specifically, surveys done using seismic equipment to map the land beneath the ice. And he finds something shocking. The coastline on the Piri Reis map matches the actual coastline of Antarctica beneath the ice. Not perfectly, there are distortions. But the general shape, the bays, the geographical features, they correspond. How? Piri Reis himself provides a partial answer. In notes on the map, he explains that he compiled it from older source maps. Maps from the Library of Alexandria. Maps from ancient cartographers. He didn't survey these coastlines himself. He copied them from earlier works, some dating back centuries, some possibly millennia. So the question becomes, who made those original maps? Who surveyed Antarctica when it wasn't covered in ice? Because that's what the map shows. Not an ice-covered wasteland, but a coastline, land, geography. Antarctica hasn't been ice-free for at least 6,000 years. Some estimates put it much longer. The ice sheets are ancient, miles thick, yet someone at some point mapped the coast as it appeared without ice, and that map survived. Copied and recopied through generations, preserved in libraries, eventually finding its way to Piri Reis, who incorporated it into his 1513 world map. Let that sink in. A map showing geographic knowledge that shouldn't exist. Shouldn't be possible without modern technology. Yet there it is, drawn on gazelle skin, sitting in a Turkish palace. But the Piri Reis map isn't alone. Let's talk about the Orontius Phineus map. Created in 1531 AD by a French cartographer named Oronce Fine, known by his Latinized name, Orontius Phineus. This map also shows Antarctica, but with even more detail. It shows the continent as two distinct land masses separated by a waterway, mountains, rivers, interior features. For centuries, this was dismissed as imagination. Phineus didn't know what Antarctica looked like, so he just made it up, filled in the blank spaces with plausible guesses. But then, in the 1950s and 60s, researchers using ice-penetrating radar made a discovery. Antarctica is indeed two landmasses, East Antarctica and West Antarctica, separated by a trench that would be filled with water if the ice were removed. The mountains and rivers shown on the Phineus map correspond roughly to actual geographic features beneath the ice. How did Phineus know this in 1531? He didn't have radar. He didn't have satellites. He didn't have expeditions drilling through miles of ice. Like Piri Reis, he must have been working from older sources. Maps that showed Antarctica as it existed before the ice. Maps created by someone who actually surveyed the continent. But who? And when? Let's go further. The Boache map. Created in 1737 by French geographer Philippe Boache. This map shows Antarctica divided into two distinct ice-free islands. Again, a detail that wouldn't be confirmed until modern ice-penetrating technology revealed the land beneath the ice. The Mercator maps from the 16th century. The Zeno map showing Greenland without ice. Over and over, we find medieval and Renaissance cartographers incorporating details into their maps that they couldn't possibly know from contemporary exploration. They're copying from older sources. Sources that show the world as it existed thousands of years ago. Sources that required actual survey, actual observation, actual knowledge. Now let's talk about longitude. Measuring latitude, how far north or south you are, is relatively straightforward. You measure the angle of the sun at noon, or you measure the angle of Polaris above the horizon. Ancient navigators could do this with simple instruments, but longitude, how far east or west you are, is much harder. You need to know the exact time at your location and compare it to a reference time at a fixed location. The difference tells you how far you've travelled east or west, but precise timekeeping at sea was nearly impossible until the 18th century. Ships didn't have accurate clocks. Pendulum clocks don't work on rolling decks. It wasn't until John Harrison invented the marine chronometer in the 1760s that accurate longitude measurement became practical. Before that, longitude was guesswork. Sailors used dead reckoning, estimating position based on speed and direction. It was imprecise. Maps from the medieval and Renaissance periods show massive distortions in east-west measurements because longitude couldn't be accurately determined. Yet some ancient maps show correct longitude. The Piri-Reis map, when analysed, shows longitude measurements that are surprisingly accurate, more accurate than they should be for 1513. More accurate than most maps from the 18th century before the chronometer was invented. How? Charles Hapgood, a professor of history at Keene State College, became fascinated by these maps in the 1950s and 60s. He studied them extensively. He wrote books analysing their accuracy, and he came to a controversial conclusion. The source maps used by Piri-Reis, Phineas, Boache, and others were created by an advanced ancient civilization with sophisticated navigation and cartography techniques. A civilization capable of surveying the globe with precision. A civilization that existed before recorded history. Hapgood called them the ancient sea kings. A maritime culture, explorers, mapmakers, people who sailed the world's oceans and charted its coastlines when those coastlines looked very different from today. This civilization, Hapgood argued, predated the Ice Age floods. They mapped Antarctica when it was ice-free or partially ice-free. They mapped coastlines that are now submerged, and their maps survived, preserved in libraries. Copied by later cultures who no longer understood what they were looking at. Mainstream cartographers and historians largely rejected Hapgood's theories. Too speculative, they said. The similarities between ancient maps and modern surveys are coincidental or exaggerated. The maps are inaccurate artistic interpretations, not precise surveying. But Hapgood had support from an unlikely source, the U.S. Air Force. In 1960, the Air Force's Cartographic Division reviewed Hapgood's analysis of the Piri-Reis map. Their conclusion: the map shows Antarctica as it would appear without ice, and the geographic features correspond to modern surveys. They couldn't explain how this was possible, but they confirmed the accuracy. So we're left with a mystery: maps that shouldn't exist. Maps showing knowledge that requires technology we assume didn't exist thousands of years ago. Technology for navigation, surveying, and possibly even aerial observation. Because here's another troubling detail. Some of these maps show accuracy that seems impossible without an elevated perspective, without seeing the curvature of the Earth. Without aerial or even orbital observation, the Piri-Reis map uses a projection technique, a way of representing the spherical Earth on a flat surface that's sophisticated, not perfect, but sophisticated. The kind of projection you'd use if you're looking at Earth from above, from altitude. How do you create accurate maps of a spherical Earth without understanding that it's spherical? How do you account for curvature without seeing that curvature? Medieval Europeans believed the Earth was flat, or at least many did. The idea of a spherical Earth existed among educated scholars. Greek philosophers had figured it out centuries earlier, but practical cartography still struggled with projections. Yet maps from thousands of years earlier show projection techniques that suggest the mapmakers knew they were mapping a sphere, and not just knew intellectually, but could see it, could observe it from a perspective that revealed the curvature. From where? How high would you need to be? High enough to see significant portions of the globe at once. High enough to observe curvature. Mountains? No. You'd need altitude far beyond any mountain. You'd need aircraft. Or satellites. Or something equivalent. This is where the theories get wild. Some researchers suggest ancient aviation, lighter than aircraft, hot air balloons, dirigibles. There are ancient texts that describe flying machines, the Vimanas of Indian epics, for example. But these are mythology, stories, not evidence of actual technology. Or are they? What if some myths preserve memories of real capabilities? Capabilities lost when the civilization that developed them was destroyed. We don't know. We're speculating, filling in gaps with guesses, because the evidence is fragmentary and the conventional explanations don't quite fit. But the maps exist, real maps, in real museums, drawn by real cartographers who cited real ancient sources. The Piri Reis map is in Topkapi Palace in Istanbul. You can visit it, you can see it with your own eyes, the gazelle skin, the faded colours, the impossible coastline. The Orontius Phineas map is in the Library of Congress. The Boache map is in the French National Library. These aren't forgeries or hoaxes. They're historical documents, verified, authenticated. And they show things they shouldn't show. Let's think about what this means. If these maps are copying accurate ancient sources, then someone thousands of years ago had the technology and organisation to conduct a global survey, to sail the oceans, to chart coastlines, to measure longitude with precision, to understand projections and spherical geometry, that someone would need ships, navigational instruments, mathematical knowledge, record-keeping systems, institutional continuity to preserve the data over generations. That's not a tribe of hunter-gatherers. That's a civilization, an advanced civilization, one that left almost no archaeological trace except these maps. Maps copied and recopied until they reached Renaissance cartographers who didn't fully understand what they possessed. Where was this civilization? On the drowned coastlands, perhaps? Sunderland? Doggerland? The submerged continental shelves? Places that were above water during the Ice Age and drowned when the ice melted. A maritime civilization would naturally build on coasts, near harbours, near the sea, and when the sea level rose, their cities would be the first to drown, their ports, their libraries, their archives, all underwater now, hundreds of feet beneath the waves. What survived? Only what was copied, what was preserved inland, what made its way to libraries in Egypt, Babylon, Alexandria. Libraries that later burned or crumbled, but not before some cartographers made copies of copies, each generation adding new information, but also preserving the old. Until Piri Reis compiled his map in 1513, pulling together source maps from across the centuries, not understanding perhaps that the Antarctic coastline he was drawing hadn't been seen in thousands of years, just copying faithfully from the ancient sources. Picture those ancient cartographers standing on a ship's deck, measuring angles to the sun and stars, calculating position, sketching coastlines, recording depths, creating a map that would outlast their civilization, outlast the catastrophe, outlast the drowning, Their cities are gone. Their ships rotted to nothing. Their names forgotten. But their maps survived. Fragments of them, anyway. Enough to show us that someone, long ago, knew the world, mapped it, sailed it, understood it, and then the waters rose, the ice melted, the coastlines changed, and the maps became relics, mysteries. Impossible documents showing a world that no longer existed. Let these images drift through your mind as sleep approaches. The old cartographers, bending over parchment by candlelight, copying carefully from scrolls that are already ancient. Preserving knowledge they don't fully understand. Knowledge of coastlines that disappeared beneath the waves. The maps are silent. They don't explain themselves, they just show what was, show what someone knew. Show that the world was different once, and someone remembered, someone mapped the earth, someone saw it whole, someone left us clues written in coastlines and latitudes. The question isn't whether the maps exist. They do. You can see them, touch them, measure them. The question is, who made the originals? Who sailed those seas? Who saw Antarctica without ice? The maps are copies of copies. But somewhere, lost to time, someone saw the world from above, or perhaps someone showed them. Sleep now. The maps will wait. They've waited this long, they can wait another night. The coastlines beneath the ice remember, the old sailors remember, and in the morning, when you wake, the mystery will still be there, waiting, drawn on gazelle skin, preserved in libraries, whispering secrets about a world before the flood. Good night, navigators. Your maps endure. Imagine holding something in your hand that shouldn't exist, a device, an artifact, something that makes you question everything you thought you knew about the past. You turn it over, examine it, and you realize this is too advanced, too sophisticated, too wrong for the time period it's supposed to be from. This feeling, this cognitive dissonance, is what archaeologists experience when they encounter out-of-place artifacts, objects that don't fit the timeline, that demonstrate knowledge or capability that shouldn't exist yet. We assume technology progresses linearly, from simple to complex, from primitive to advanced, Stone Age to Bronze Age to Iron Age to Industrial Age to Information Age, a steady march forward. Always improving, always advancing, but history doesn't always work that way. Sometimes we lose knowledge, sometimes capabilities that existed in the past vanish. Sometimes we have to rediscover what our ancestors already knew. Let's start with something small, something you could hold in your hand if you were allowed to touch it, the Baghdad Battery. In 1936, Wilhelm König, a German archaeologist working in Iraq, discovered several curious objects in the basement of the Baghdad Museum. Clay jars. Nothing unusual about that. Ancient Mesopotamia produced thousands of clay jars for storing oil, wine, grain, but these jars were different. Inside each one was a copper cylinder, and inside each copper cylinder was an iron rod. The cylinder was sealed at the bottom with an asphalt plug. The rod was suspended in the centre, not touching the sides. König looked at these objects and recognised something. The design, the configuration, it looked like a galvanic cell. A battery. He published his theory in 1940. These jars, he argued, were used to electroplate objects, to coat them with a thin layer of gold or silver using electricity generated by the chemical reaction between the copper, iron, and an acidic electrolyte, perhaps vinegar or wine. the archaeological establishment was skeptical. Batteries weren't invented until Alessandro Volta created the voltaic pile in 1800 AD. These jars dated to around 250 BC to 250 AD, over 2,000 years earlier. Surely Koenig was wrong. These were just jars. The copper and iron were coincidental, not functional, but then someone tested the theory. In 1940 and later in more controlled experiments, researchers built replicas of the Baghdad battery. They filled them with vinegar, grape juice, acidic solutions, and they worked. The devices generated approximately 1 to 2 volts of electricity. Not much, but enough. Enough to electroplate jewellery. Enough to prove that the design was functional. Whether the ancient Mesopotamians actually used them for this purpose remains debated. There's no direct evidence of electroplating in the archaeological record, though gold-plated objects exist, and the plating is sometimes remarkably thin and uniform. But the devices exist. Real objects in museums, demonstrating that someone, 2,000 years ago, created a configuration that generates electricity. Whether they understood what they were doing, whether they knew they were harnessing electrochemical reactions, we don't know, but they built it, and it works. Now, let's talk about Damascus steel. Damascus steel blades were legendary. Forged in the Middle East from roughly 300 BC to 1700 AD, these swords and knives had properties that seemed almost magical. They were incredibly sharp, strong yet flexible. They could cut through inferior blades, cut through silk scarves. The steel had a distinctive watery pattern on its surface, flowing lines that looked like wood grain or rippling water. Warriors prized Damascus steel. Crusaders encountered it during the medieval period and were astounded. Their European blades couldn't match its quality, and then around 1700 AD, the technique was lost. Bladesmiths stopped producing true Damascus steel. The knowledge vanished. Later, swordsmiths tried to recreate it using pattern welding, layering different types of steel, but it wasn't the same. For centuries, we didn't know how Damascus steel was made. We had the swords, we could examine them, but we couldn't replicate the process. Then, in the late 20th century, metallurgists began studying Damascus steel using electron microscopes, and they discovered something extraordinary. The steel contains carbon nanotubes, structures at the molecular level, cylindrical molecules of carbon atoms arranged in a lattice. These nanotubes give the steel its strength and flexibility. They were only discovered by modern science in 1991. Yet there they are, in blades forged over 1,000 years ago. How did ancient smiths create carbon nanotubes without understanding molecular chemistry, without electron microscopes, without modern metallurgical science? They did it through process. Trial and error, using specific ores from specific regions, particularly India and Sri Lanka, that contained trace elements, heating the steel to precise temperatures, adding organic materials during forging. The exact recipe remains somewhat mysterious, but researchers have managed to recreate Damascus steel using traditional methods. The ancient smiths didn't know they were creating nanotubes. They just knew the process worked, knew it produced superior blades. And they guarded the technique carefully, passed it down through apprenticeships, until, for reasons still unclear, the knowledge was lost. We call ourselves advanced. We have electron microscopes and molecular chemistry. Yet we lost the ability to make Damascus steel and had to rediscover it through modern science. What else have we lost? What other techniques existed that left no written record and simply vanished when the last practitioner died without passing on the knowledge? Let's talk about Roman concrete. The Romans built structures that still stand 2,000 years later. The Pantheon in Rome, built in 126 AD. Its dome remains the largest unreinforced concrete dome in the world, nearly 2 millennia old. Still structurally sound, Roman aqueducts, bridges, harbours, roads, concrete structures exposed to weather, earthquakes, erosion, and they endure. They persist. Often in better condition than modern concrete that crumbles after a few decades. How? Modern concrete is strong when it's fresh, but degrades over time, particularly when exposed to seawater. The salt water seeps in, reacts with the calcium hydroxide, causes cracks, erosion, structural failure. Roman concrete, especially the kind used in marine structures like harbour walls, gets stronger over time. After 2,000 years underwater, it's more durable than the day it was poured. For a long time, we didn't know why. We had the structures. We could analyse them chemically, but we couldn't quite replicate the properties. Then researchers discovered the secret. The Romans used volcanic ash, particularly a type called pozzolana, in their concrete mix. When exposed to seawater, the volcanic ash reacts with the salt water in a beneficial way. It creates new mineral crystals, specifically a rare mineral called aluminum tobermarite, that fill in cracks and strengthen the concrete. It's self-healing. Self-reinforcing. Modern concrete doesn't do this. Our formulations are different. We use Portland cement. It's cheaper, easier to produce, but it doesn't have the long-term durability of Roman concrete. We could make Roman-style concrete today. The technique is understood now. But we largely don't. It's more expensive, requires specific materials, and modern construction doesn't prioritise structures lasting 2,000 years. We build for decades, maybe a century, not millennia. The Romans built for eternity. And their concrete knew the secret. Now let's talk about Greek fire. Byzantine Empire. 7th century AD. The empire is under siege. Arab fleets threaten Constantinople. The Byzantine navy needs an advantage, something to turn the tide. And they unveil a weapon, a liquid fire, sprayed from ships through bronze tubes. It burns on water, can't be extinguished with water. In fact, water makes it burn hotter. Soldiers describe it as terrifying, unstoppable. Burning ships, burning men, burning the sea itself. Greek fire saved Constantinople multiple times, gave the Byzantine navy a decisive advantage. For centuries, the Byzantines guarded the secret ferociously. Only a few people knew the formula. Knowledge passed from emperor to emperor, from generation to generation, and then it was lost. The Byzantine Empire eventually fell. The knowledge of Greek fire vanished with it. No written formula survived. Or if it did, it's never been found. We have descriptions of its effects, accounts of battles where it was used, but we don't know exactly what it was made of. Modern chemists have theories. Probably a petroleum-based mixture. Perhaps naphtha, quicklime, sulfur, saltpeter. Some combination that ignites on contact with water, that burns intensely, that clings to surfaces like napalm. We've recreated approximations. Modern incendiary weapons that behave similarly, but the exact formula? Lost. Another example of knowledge that simply vanished when the last person who knew it died without recording it. Let's shift from weapons to art. The Lycurgus cup. It's a Roman glass vessel made around 400 AD, housed now in the British Museum. It depicts the death of King Lycurgus from Greek mythology. Exquisite craftsmanship, beautiful detail, but that's not what makes it extraordinary. The cup is dichroic. It changes colour depending on the light. When light shines on it from the outside, it appears green. When light shines through it from inside, it appears red. For centuries, this was a mystery. Glass doesn't normally do this. How did the Romans create this effect? In 1990, researchers examined the cup under an electron microscope and discovered the secret. The glass contains nanoparticles, tiny fragments of gold and silver, each about 50 nanometers in diameter, about 1,000 times smaller than a grain of salt. These nanoparticles interact with light in specific ways, creating the color-changing effect. It's a demonstration of what modern science calls nanotechnology, manipulating materials at the molecular and atomic level to produce specific properties. The Romans didn't have electron microscopes, they didn't have nanotechnology labs, yet they created this cup. Somehow incorporated nanoparticles into the glass in precise concentrations to achieve the dichroic effect. How? We don't fully know. Probably by adding tiny amounts of colloidal gold and silver to the molten glass. Probably through experimentation. Probably through techniques passed down through glass-making guilds. But the technique was lost. Later, Roman glassmakers couldn't replicate it. Medieval glassmakers couldn't replicate it. It wasn't until modern nanotechnology that we understood what the cup contains and could begin to recreate the effect. Now let's talk about precision. Ancient precision. In the Cairo Museum, there are stone vases, granite, diorite, basalt, hard stones, very hard, difficult to work even with modern tools. These vases are beautifully carved, symmetrical, smooth, with thin walls and elegant shapes. Some have handles, some have long narrow necks. Some have compound curves that seem impossible to carve from solid stone. And when you measure them precisely, when you use calipers and micrometers to check their dimensions, you find something remarkable. The tolerances are incredibly tight. Some vases are symmetrical to within 0.01 inches, 1,000th of an inch. That's the thickness of a human hair. That's precision that requires sophisticated tools, machine tools, computer-guided cutting. Yet these vases date to the Old Kingdom, around 2600 BC, before the pyramids, before iron tools. The Egyptians had copper tools. Copper is soft. It can't cut granite efficiently. How are these vases made? Egyptologists suggest various techniques. Tube drills, hollow reeds with sand as an abrasive, copper saws, patient grinding, hours and hours of work, maybe, but achieving tolerances of 0 to 1 inches. With these methods, it's theoretically possible, but extraordinarily difficult. It would require not just skill, but measuring instruments capable of detecting errors at that scale. Did they have such instruments? We don't know. The vases exist. You can see them. Touch them. Measure them. The precision is real. Similarly, in Egypt, there are drill holes in granite blocks, core samples extracted from the stone. And when you examine these cores, you see spiral grooves, regular, evenly spaced. The grooves suggest a drill rotating at high speed, feeding downward at a consistent rate. cutting through granite as if it were butter. Modern diamond-tipped drills can do this, but copper drills with sand abrasive, the math doesn't quite work. The feed rate suggested by the grooves is too fast, the cutting is too clean. Engineer Christopher Dunn has studied these drill cores extensively. He argues that the precision suggests advanced tooling. Perhaps even ultrasonic drilling, vibrating tools that use high-frequency oscillation to cut through hard stone. Mainstream Egyptology rejects this. There's no evidence of such tools in the archaeological record. No ancient ultrasonic drills sitting in museums. But the drill holes exist, the precision exists, and the conventional explanations strain credibility. Let's go to South America, to Ollantaytambo in Peru. Ollantaytambo is an Inca site, stone walls, terraces, temples. And at the top, massive blocks of pink granite. Each block weighs many tons. Some weigh over 50 tons. The granite isn't local. It came from a quarry on the opposite side of the valley, about 6 miles away, across a river. Over mountainous terrain, at high altitude. How were these stones moved? The Inca had no wheels, no draft animals capable of pulling such loads. Llamas can carry packs but can't pull carts or sleds loaded with 50-ton stones. The conventional answer, manpower, thousands of workers, ropes, ramps, rolling the stones on logs, sliding them on wet clay. But the terrain doesn't make this easy. Moving a 50-ton block uphill over 6 miles of mountains. The logistics are staggering. The energy required is immense. And when the stones arrived, they were placed with precision, fitted together using polygonal masonry. Stones with multiple sides, 6 sides, 8 sides, 12 sides, interlocking perfectly. No mortar, no gaps, just stone on stone. To create this, you need to shape each stone to fit its neighbours. Each face has to match precisely. One slight error, and the stone won't fit. You'd have to start over. How many attempts did it take? How many stones were discarded because they didn't fit? Or did they get it right the first time? Did they have techniques we don't understand? Templates, models, some method of precision shaping that left no archaeological trace? We don't know, we just see the results. Massive stones, perfectly fitted, impossibly moved. Let these thoughts settle. Picture the ancient craftsman, the Roman glassmaker creating a cup that changes colour. Not knowing about nanoparticles, but knowing the recipe works. The Byzantine sailor spraying Greek fire from a bronze tube, not understanding the chemistry, but trusting the formula. The Egyptian artisan drilling through granite with a precision that rivals modern machinery. They didn't have our science, they didn't have our terminology. They didn't understand molecules or chemical reactions or feed rates, but they had results, they had techniques, they had knowledge that worked. And when those techniques were lost, when the last practitioner died, when the library burned, when the civilization fell, the knowledge vanished. We call them primitive, but they could do things we struggle to understand. Things we've had to rediscover. Things we still can't fully replicate. Technology doesn't always progress. Sometimes it circles. Sometimes it's lost and found and lost again. Perhaps we're the ones who forgot. Sleep now. The artifacts wait. The Baghdad battery, the Damascus blade, the Lycurgus cup, the precision vases. Silent witnesses to knowledge that once was and might be again. The past is not always primitive. Sometimes it's just past. different, lost, but not lesser. Good night, craftsman. Your works endure, even if we don't understand them. Every cell in your body contains a library, a molecular archive. 4 billion years of evolutionary history written in the language of DNA. Adenine, thymine, guanine, cytosine. 4 letters, 3 billion base pairs. The complete instruction manual for building a human being. But DNA doesn't just tell the story of you. It tells the story of everyone who came before you. Your parents, your grandparents, your ancestors, stretching back thousands, tens of thousands, hundreds of thousands of years. Every mutation, every adaptation, every journey across continents, every survival against the odds. It's all there, written in code, waiting to be read. And when scientists started reading it, when they developed the tools to sequence genomes, to compare populations, to trace lineages through time, they discovered something remarkable. The genetic record doesn't always match the archaeological record. Doesn't always fit the neat narratives we've constructed about human history. Sometimes DNA reveals peoples who left no other trace. Ghost populations, humans who lived, migrated, mixed with other groups, and then vanished. Known only through the genetic signatures they left behind in us. Let's start with the most famous ghost, the Denisovans. In 2008, Russian archaeologists were excavating a cave in southern Siberia. Denisova Cave. They'd been working there for years, finding stone tools, animal bones, evidence of human occupation spanning tens of thousands of years. Then they found a finger bone, small, belonged to a child, maybe a girl. Nothing particularly unusual, except when they carbon dated it, it was old, around 41,000 years old. They sent a sample for DNA analysis. Just routine. They expected it to come back as either Homo sapiens or Neanderthal. Those were the known human species in Eurasia at that time. But when the results came back, they showed something else. This wasn't modern human DNA, wasn't Neanderthal DNA. It was something different, a distinct lineage. A species of human that nobody knew existed. They called them Denisovans. After the cave where they were found, here's what we know about Denisovans. Almost nothing, physically at least. We have the finger bone, a few teeth, some bone fragments. Not enough to reconstruct what they looked like. Not enough to fill a museum display case. But we have their genome. Complete genetic sequence extracted from that finger bone. And it tells us everything. Denisovans were a distinct hominin species. They split from the lineage leading to Neanderthals and modern humans around 400,000 years ago. They lived in Asia, Siberia certainly, but genetic evidence suggests they ranged much further. Southeast Asia, Oceania, maybe even the Americas. And here's the remarkable part. They're not extinct. Not entirely. You, if you're of East Asian, Southeast Asian, Oceanian, or Native American descent, probably carry Denisovan DNA. Small amounts, maybe 1 to 5% of your genome. Fragments of Denisovan genes mixed into your ancestry through interbreeding thousands of years ago. Modern humans encountered Denisovans, interbred with them, and some of those Denisovan genes provided advantages. Genes for high-altitude adaptation, for example. Tibetans carry a Denisovan gene variant that helps them thrive at high elevations where oxygen is scarce, inherited from ancient interbreeding, a gift from a ghost species. Denisovans are known almost entirely from DNA, one cave, a few bone fragments. but their genetic legacy is global. They were real, they were human, they were us. Just a different branch of the human family tree. And they weren't alone. The genetic data suggests other ghost populations. Lineages that show up in DNA but have no archaeological remains, no fossils, no artifacts. Just genetic signatures indicating that somewhere, sometime, there were groups of humans who lived, contributed to the gene pool, and then disappeared without leaving physical evidence. In Africa, DNA studies have identified at least 2 ghost populations. Ancient human lineages that mixed with modern human ancestors before disappearing. We don't know what to call them. We don't know what they look like. We just know they existed because their genetic markers persist in modern African populations. Think about what this means. There are entire branches of the human family tree known only through DNA, species or populations that left no bones, no tools, no art, no trace, except the code written into our cells. How many others were there? How many human groups lived and died without leaving anything we can find? How much of our history is invisible? Now let's talk about something controversial. Ancient transoceanic contact. The conventional narrative of human migration is fairly straightforward. Humans evolved in Africa. Some populations left Africa around 60,000 to 70,000 years ago. They spread through the Middle East into Europe and Asia. Some crossed into the Americas via the Bering Land Bridge around 15,000 years ago. Different continents remained largely isolated from each other until European exploration in the 15th century AD. Clean, linear, isolated populations developing independently, but the genetic evidence sometimes suggests otherwise, suggests contact, suggests mixing, suggests that humans were moving around more than we thought, crossing oceans, connecting continents. Take the Phoenicians, ancient maritime traders from the eastern Mediterranean. They established colonies throughout the Mediterranean and beyond. Carthage, Cadiz, trading networks stretching across the known world. But how far did they go? In 1996, a German archaeologist named Rosalie David examined ancient Egyptian mummies in the Munich Museum. As part of a standard analysis, she tested for organic compounds, drugs, resins, materials used in mummification. The results were unexpected. Several mummies tested positive for cocaine and nicotine. Cocaine comes from coca plants, native to South America. Nicotine, in the concentrations found, come from tobacco, also native to the Americas. How did Egyptian mummies from 1000 BC contain American plant compounds? The Americas weren't discovered by the Old World until 1492 AD. There was no contact, no trade, no way for South American cocaine to reach Egypt. Or was there? The findings were controversial. Some researchers suggested contamination. The mummies had been handled by many people over the centuries. Maybe someone smoked tobacco near them. Maybe cocaine was introduced accidentally. But the compounds were found deep in the tissues. Not surface contamination, integrated into the body at the time of death or mummification. Other researchers suggested that the plants existed in Africa or Asia, but went extinct. But there's no archaeological or botanical evidence of coca or tobacco outside the Americas before European contact. Or maybe there was contact. Maybe ancient sailors, Phoenicians, Egyptians, or others crossed the Atlantic, reached South America, traded, brought back exotic plants, and the records of these voyages were lost. It sounds impossible, but humans have been building boats for tens of thousands of years. Crossing oceans isn't as technologically difficult as it sounds. The Polynesians navigated the Pacific using outrigger canoes covering thousands of miles of open ocean. If they could do it, why not others? Let's talk about the Polynesians. Because their story is extraordinary. The Pacific Ocean is vast. It covers a third of Earth's surface. Scattered across this immensity are thousands of islands, some large, most tiny. Isolated specks of land separated by hundreds or thousands of miles of water, and humans reach them, all of them. Polynesians settled nearly every habitable island in the Pacific: Hawaii, Easter Island, New Zealand, Madagascar off the coast of Africa, Fiji, Samoa, Tonga, Tahiti. These weren't accidents. Polynesians were master navigators. They read the stars, the waves, the clouds, the birds. They had mental maps of the ocean encoded in chants and stories. They built sophisticated outrigger canoes capable of long ocean voyages. DNA evidence confirms the extraordinary scope of their migrations. Polynesian DNA shows up across the Pacific. And it shows something else, something unexpected: sweet potato. Sweet potato is native to South America, yet it was a staple crop in Polynesia before European contact. The Polynesian word for it, kumara, is similar to the Quechua word kumar. The Quechua are native to the Andes. How did a South American crop reach Polynesia before Columbus? Two possibilities. Either the sweet potato drifted across the ocean, seeds floating on currents for thousands of miles, or humans carried it. Polynesians voyaging to South America, or South Americans voyaging to Polynesia. Recent DNA studies suggest it was the former. Polynesians may have reached South America around 1200 AD, centuries before European contact. They may have met indigenous peoples, traded, and brought the sweet potato back. If Polynesians could cross the Pacific in outrigger canoes, what could other ancient peoples do? Now let's talk about a genetic mystery that's puzzled researchers for decades. Rh negative blood. Most humans have Rh positive blood. The Rh refers to the rhesus factor, a protein on the surface of red blood cells. If you have the protein, you're Rh positive. If you don't, you're Rh negative. About 85% of humans are Rh positive. The remaining 15% are Rh negative, but the distribution isn't even. Rh negative blood is most common in the Basque people of northern Spain and southern France. Among the Basques, up to 35% are Rh negative. Why? We don't know. Rh negative blood doesn't provide an obvious evolutionary advantage. In fact, it can be a disadvantage. If an Rh negative mother carries an Rh positive baby, her immune system may attack the baby's blood cells, causing complications. Modern medicine can prevent this, but before medical intervention, it would have been dangerous. So why does Rh negative blood persist? And why is it concentrated in the Basque population? The Basque people are unusual in other ways too. Their language, Euskara, has no known relatives. It's a language isolate, unrelated to any other European language, unrelated to Indo-European, the family that includes English, French, Spanish, German, Russian, Hindi. It's as if the Basques are remnants of an older population, a population that existed in Europe before the Indo-European migrations. Before the language families we know spread across the continent. Genetic studies support this. Basque DNA shows distinct patterns. They have genetic markers that are rare or absent in neighbouring populations. Markers suggesting they've been relatively isolated for thousands of years, preserving ancient lineages. Are they descendants of a pre-flood population? Survivors from a time before the catastrophic sea level rise? We don't know, but they're different, genetically, linguistically, a mystery written into the European genome. Now, let's talk about something recent. Something that changes the narrative of human migration to the Americas. For decades, the prevailing theory was that humans first reached the Americas around 13,000 to 15,000 years ago. They crossed from Siberia to Alaska via the Bering Land Bridge, a strip of land exposed when sea levels were lower during the Ice Age. They moved south through an ice-free corridor and populated North and South America. The Clovis first theory. Named after distinctive stone tools found at archaeological sites throughout North America, but recent evidence challenges this. Archaeological sites in South America, Monteverde in Chile, for example, date to 18,500 years ago. Older than Clovis, and coastal sites suggest that some migrants may have travelled by boat along the Pacific coast rather than through the interior ice corridor. DNA evidence adds another twist. Some Native American populations carry genetic markers that aren't fully explained by the Bering Strait migration, markers that suggest possible contact with other populations, perhaps Australasian populations, perhaps ancient seafarers. In 2015, researchers analysing DNA from Amazonian tribes found genetic signatures similar to indigenous Australians and Melanesians, not closely related, but more similar than expected if all Native Americans descended solely from Siberian populations. This suggests a possible second migration, or contact, or mixing that we don't yet understand. Humans reaching the Americas by routes we haven't considered. Perhaps by sea, perhaps following coastlines that are now submerged. The ocean hides much. The sea level was 400 feet lower during the Ice Age. The coastlines where ancient peoples might have lived, travelled and built are underwater now. We can't excavate them easily, can't survey them thoroughly. The evidence is drowned, but DNA persists, passed down through generations, carrying the genetic echoes of journeys we can't see in the archaeological record. Let's talk about one more mystery, the genetic bottlenecks. A genetic bottleneck occurs when a population crashes, when most individuals die and only a small group survives. The survivors carry only a fraction of the original genetic diversity. When the population rebuilds, everyone descends from that small group. The genetic variation is limited, reduced. Human DNA shows evidence of bottlenecks, severe ones. Around 70,000 years ago, as we discussed earlier, the human population may have crashed to as few as 3,000 to 10,000 breeding individuals. The Toba catastrophe, the volcanic winter, near extinction, but that's not the only bottleneck. There are others, smaller, more localized. Populations that nearly died out but survived. Each bottleneck leaves a signature, a pattern of reduced genetic variation, shared markers indicating descent from a small founder population. These bottlenecks suggest catastrophes, events that killed most of the population, volcanic eruptions, climate shifts, floods, plagues, near extinctions followed by recovery. We survived, obviously, we're here, 8 billion of us. But the genetic record shows that survival was never guaranteed, that human history is punctuated by close calls, by populations collapsing and rebuilding, by lineages vanishing and others enduring, and the survivors carried forward the genes we have now, the adaptations, the traits, the fragments of Denisovan DNA that help us breathe at high altitude. The Neanderthal DNA that affects our immune systems. The ghost population markers that we can't fully explain. We are walking libraries, archives of every journey, every survival, every mixing, every bottleneck, every migration. The genetic code doesn't lie, it records faithfully. Mutations accumulate at measurable rates, lineages diverge, populations mix, and the patterns tell stories. Stories of peoples we've never heard of. Journeys that left no written record. Catastrophes preserved only in the narrowing of genetic diversity. Picture yourself at the molecular level, zooming into a cell, into the nucleus, into the tightly coiled DNA. And if you could read it, if you could decode every base pair, trace every lineage, follow every mutation back through time, you'd see them. The Denisovans, the ghost populations of Africa, the ancient travellers who crossed oceans, the survivors of bottlenecks, the refugees from the flood, all of them, written into you, whispering. Let these whispers drift as you settle into sleep. The code is patient. It's been preserving these stories for thousands of years. It can wait through one more night. The DNA remembers, even when we forget, even when the archaeological record is silent, even when the coastlines drown and the libraries burn, the genes persist, passed from parent to child, from generation to generation, from the survivors to us. Sleep now. You are the library, the archive, the evidence. Good night, descendants. Your ancestors endure in you. Words are time machines. They carry the past forward. Every language is an archive of history, culture, migration, and contact. When you speak, you're using sounds and structures inherited from ancestors who spoke thousands of years ago. And sometimes, when you look closely at languages separated by oceans and continents, you find something curious, something that shouldn't be there. Similarities, shared words, similar structures, symbols that repeat across cultures with no known contact. Coincidence? Perhaps. Language families evolve. Humans across the world make similar sounds. We all have the same vocal apparatus, the same cognitive structure. Maybe we independently arrive at similar words for similar concepts, but sometimes the similarities are too specific, too precise, too unlikely to be accidental. Let's start with the most mysterious language in Europe, Euskara, Basque. The Basque people live in the Pyrenees Mountains, straddling the border between Spain and France. They've been there for thousands of years, and they speak a language that doesn't fit. Every other language in Europe belongs to a family. Indo-European, mostly. English, French, Spanish, German, Russian, Greek, Hindi, they're all related. They descended from common ancestor language spoken thousands of years ago. You can trace the connections. Similar words, similar grammatical structures. Linguists can reconstruct the family tree, but Basque doesn't fit on that tree. It has no known relatives. No parent language, no sibling languages. It's an isolate. A linguistic island. Basque words don't resemble Spanish words, don't resemble French words, don't resemble any Indo-European language. The grammar is completely different. The vocabulary is unique. It's as if the Basques are speaking a language from an earlier time, a pre-Indo-European language, a remnant of whatever languages were spoken in Europe before the Indo-European migrations swept across the continent around 4,000 to 6,000 years ago. Linguists have tried to find connections. Maybe Basque is related to ancient Iberian languages, or to languages in the Caucasus Mountains, or to Sumerian, or to ancient North African languages. No clear connection has been established. Basque stands alone. This suggests isolation. The Basque people preserved their language through millennia, while surrounding populations adopted Indo-European languages, preserved it through invasions, migrations, cultural shifts, held onto it when everyone around them changed. Why? How? What were they preserving? Maybe just cultural identity. Language is powerful. It binds communities, defines identity, or maybe they're remembering something, preserving something from before the catastrophe, before the flood, a language spoken on lands now drowned, a language carried by survivors into the mountains where it persisted while the rest of Europe changed. We don't know, but the Basques are different. Genetically, linguistically, a mystery written in words. Now let's look at something broader. Shared words across language families. Certain concepts appear in languages worldwide with surprisingly similar words, not identical, but similar enough to notice. Water, for example. In Latin, aqua. In Sanskrit, apius. In Proto-Indo-European reconstruction, H2 The connection makes sense. These languages are related. But then you find similar words outside Indo-European. In various African languages, water-related words often contain similar sounds. In some Native American languages too. Mother. One of the most universal words. English, mother. German, Mutter. Latin, mater. Greek, meter. Sanskrit, matter. Russian, mat. Hindi, ma. All Indo-European. Expected. But also Chinese, mama. Swahili, mama. Quechua, mama. Georgian, mama. Hawaiian, makuahine, different, but ma appears in child language. Korean, ioma. The ma sound for mother appears globally. Linguists explain this as a natural sound. Babies make ma sounds early. Simple repetition. So cultures independently adopt mama or similar words for mother. Plausible. But why is it so universal? Why that sound specifically? Now let's talk about pyramids. Pyramids exist on multiple continents: Egypt, Mesoamerica, South America, Southeast Asia, step pyramids, smooth-sided pyramids, ziggurats. The architectural similarity is already interesting. Humans independently deciding that the best way to build a monumental structure is to stack stones in a pyramid shape. Maybe it's natural. Pyramids are stable, wide base, narrow top, structurally sound. But here's what's strange. The word. In ancient Egyptian, the word for pyramid is mer. In Mayan, similar structures are called pyramid in Spanish, but the indigenous word is similar. In various other languages, the word for pyramid or similar structures contains similar phonetic elements. Could be coincidence, could be linguistic borrowing after European contact. Spanish brought the word pyramid to the Americas, after all. But then you find indigenous words for sacred mountains, temple structures, burial mounds, concepts related to pyramids, and they sometimes contain similar sounds. Pyre relates to fire in Greek, pyramids as fire in the middle. Pyre relates to sacred or fire in various Asian languages. Tenuous connections, easy to dismiss as pattern seeking, but the similarities accumulate. Let's talk about symbols, specifically petroglyphs. Petroglyphs are images carved into rock. Ancient humans carved them worldwide: spirals, circles, animal figures, human figures, abstract symbols. In Australia, indigenous peoples carved petroglyphs depicting ancestral spirits, animals, and symbols with cultural significance. Some are tens of thousands of years old. In South America, specifically in regions of Peru, Chile, and Argentina, archaeologists have found petroglyphs, and sometimes the symbols are strikingly similar. Spirals in Australia, spirals in South America, not just any spirals. Specific types: similar execution, similar context, often near water sources or sacred sites, concentric circles, handprints, geometric patterns, appearing on both continents, separated by the Pacific Ocean. Separated by thousands of miles. Coincidence? Humans universally drawn to similar, simple shapes? Maybe. A spiral is a natural form. Shell's spiral. Water spirals. The brain might be predisposed to draw spirals. But some similarities are more specific, combinations of symbols, arrangements, patterns that repeat across continents with remarkable consistency. Now let's talk about the legends, the teachers, the civilizing gods. Nearly every ancient culture has a story about a teacher, a figure who came from somewhere else and brought knowledge. Taught agriculture, astronomy, writing, law, civilization. In Mesoamerica, it's Quetzalcoatl. The feathered serpent, described as a bearded man, light-skinned in some accounts. He came from across the sea, taught the people agriculture, mathematics, astronomy, and the calendar. Then he left, promising to return. Or in South America, it's Viracocha, also described as bearded, light-skinned, tall. He appeared after a great flood, taught the survivors how to rebuild civilization, how to farm, how to build. Then he walked into the ocean and disappeared. In Egypt, it's Thoth, the god of wisdom, the inventor of writing, the teacher of astronomy and mathematics, associated with the moon and with sacred knowledge. In Sumer, it's the Apkallu, 7 sages who came before the flood. They taught humanity the arts of civilization. After the flood, they helped rebuild. In various cultures, there are similar figures: teachers, culture heroes, beings who brought knowledge from elsewhere. The details vary, the names change, but the pattern is consistent. Someone came, someone taught, someone left. Mainstream scholarship treats these as myths. Symbolic figures representing the gradual development of civilization, metaphors for cultural evolution. But what if there's memory embedded in the myths? Memory of real people, survivors from the drowned lands, refugees carrying knowledge, appearing to scattered post-flood populations and teaching them what had been lost. They would have seemed godlike, knowing things, building things, understanding the stars. Of course, later generations would mythologize them, turn them into gods. But the core memory might be real. A bearded man arriving by boat, teaching, then leaving. Sailors from a lost civilization, explorers, survivors, we can't know. But the similarity of the legends across cultures is striking. Now let's talk about a symbol that appears worldwide, a symbol that's been corrupted in modern times but was once sacred across continents, the swastika. Before the Nazis adopted and perverted it, the swastika was an ancient symbol appearing in cultures worldwide. It's a simple geometric form. 4 arms bent at right angles, rotating clockwise or counterclockwise. In Hinduism and Buddhism, It's a sacred symbol representing auspiciousness, prosperity, and the eternal cycle of existence. It appears on temples, religious texts, and art throughout India and Southeast Asia. In ancient Greece and Rome, the swastika appears on pottery and architecture. In Native American cultures, specifically the Navajo, Hopi, and other southwestern tribes, the swastika appears in artwork, pottery, and textiles. A sacred symbol associated with the four directions, the four seasons, the wholeness of creation. In Celtic art, swastika-like symbols appear. In ancient Nordic cultures, the swastika is associated with Thor and represents the movement of the sun across the sky. In China, the swastika appears in Buddhist and Taoist contexts. In Africa, the symbol appears in various forms across different cultures, a simple geometric symbol appearing independently across continents, plausible. Humans are drawn to symmetry, to geometric patterns. The swastika is visually appealing, easy to draw. Maybe every culture independently created it, or maybe it's older, a symbol from a common source, carried by migrants, preserved in multiple cultures, each giving it their own meaning but retaining the form. Now let's talk about numbers, specifically the number 7. 7 is sacred in an extraordinary number of cultures, 7 days of the week. 7 classical planets, Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. 7 colours in the rainbow. 7 musical notes in the diatonic scale. In Judaism and Christianity, 7 is deeply significant. God created the world in 7 days, 7 seals in Revelation, 7 deadly sins, 7 virtues. In Islam, 7 heavens, 7 earths, 7 circumambulations of the Kaaba during Hajj. In Hinduism, 7 chakras, 7 sages, 7 sacred rivers. In Buddhism, 7 factors of enlightenment, 7 treasures. In ancient Mesopotamia, 7 gates to the underworld, 7 demons, 7 layers of the ziggurat. In ancient Egypt, 7 gates, 7 sacred oils. In Chinese philosophy, the 7th month is the ghost month. 7 stars in the Big Dipper. Why 7? Why is this number so consistently sacred across unrelated cultures? Astronomically, there are 7 classical wandering stars, the Sun, Moon, and 5 visible planets. Maybe that's the origin. Everyone can see them, everyone tracks them, so 7 becomes significant. But the consistency is remarkable. The way 7 appears in religious contexts, sacred architecture, ritual practices, it's as if there's a shared template, a common understanding that 7 is special, a shared inheritance from a common source, or convergent cultural evolution. Let's talk about the proto-language hypothesis. Some linguists theorize that all human languages might descend from a single ancestral language, proto-human. The language spoken by early Homo sapiens in Africa before they dispersed across the world. As populations migrated and separated, the language would have diverged, evolved independently. After tens of thousands of years, the daughter languages would be unrecognizably different. No obvious relationship, but deep in the structure, deep in the most basic vocabulary, traces might remain. Words for fundamental concepts: mother, father, water, fire, sun, moon. Researchers have attempted to find these deep connections, looking for words that appear similar across unrelated language families, trying to reconstruct what proto-human might have sounded like. It's controversial. Most linguists are skeptical. The time depth is too great. Language changes too quickly. After 50,000 or 100,000 years, any common origin would be undetectable. Statistical noise would overwhelm any real signal. But some researchers persist. They find tantalizing hints, words that seem too similar to be coincidental, structural patterns that repeat. If humans all descend from a small population in Africa, and genetic evidence strongly suggests we do, then at some point that population spoke a language, maybe several languages, but there was a common linguistic ancestor. And maybe, just maybe, fragments of it persist, hidden deep in the vocabularies of every language. Whispers of the first words. Let these thoughts drift. Picture the ancient travellers, speaking languages we'll never hear, but leaving traces, words borrowed, symbols shared, legends told, the Basques in their mountains speaking a language that predates the Indo-European tide, the pyramids rising on 3 continents bearing similar names. The swastika appearing globally, sacred before it was corrupted. The number 7 woven through religions worldwide. The bearded teachers arriving by boat, bringing knowledge, then vanishing. Are these connections real? Or are we seeing patterns that don't exist? We can't know for certain. Language changes, symbols spread. Humans are creative. Maybe these similarities are coincidence, independent invention, convergent cultural evolution. Or maybe their memory, fragments of contact, evidence of a time when the world was more connected than we think. When sailors crossed oceans, when knowledge flowed between continents. When a common source, a mother culture, a teacher civilization, a group of survivors spread their language, their symbols, their knowledge across the world, and then the catastrophe came, the flood, the ice, the forgetting, the isolation, but the words remained, the symbols persisted, the stories survived, changed, yes, distorted by time, reinterpreted by each culture, but carrying within them a kernel of truth. A memory of connection. Sleep now. The words will wait. Languages drift and change, but the oldest words endure. Mother, father, water, sun. The first words. The shared words. The words that crossed oceans and survived millennia. Good night, speakers. Your words carry the past forward. Picture yourself standing in a museum storeroom. Cairo. The basement of the Egyptian Museum. Dim lighting, rows of shelves stretching into shadows, stone objects everywhere, statues, fragments, bowls, and on one shelf, a collection of vases, not particularly impressive at first glance. Stone vases, granite, diorite, basalt, various sizes, some with handles, some with narrow necks, ancient Egyptian, Old Kingdom, maybe earlier. But then someone hands you a measuring instrument, calipers, a micrometer, and they tell you to measure the vases, check the symmetry, the wall thickness, the precision. You start measuring and the numbers don't make sense. One vase, granite, hard stone, harder than steel on the Mohs scale. The walls are thin, maybe a 1/4 inch. The bowl is symmetrical, perfectly round. You measure the diameter at multiple points. The variation is less than 1/1000th of an inch. 1/1000th of an inch. That's 0.001 inches. That's 25 micrometers. That's smaller than the width of a human hair. You check another vase, same precision, another, same. The entire collection shows tolerances that would challenge modern machinists using computer-guided equipment. How? These vases date to around 3000 BC, maybe earlier. Some might date to the pre-dynastic period, before the pharaohs, before the unification of Egypt. The Egyptians at that time had copper tools, stone hammers, maybe bronze later, no steel, no power tools, no precision measuring instruments as far as we know, yet they created objects with tolerances of 1/1000th of an inch in granite. Let's think about what this requires. To achieve that precision, you need to measure it first. You need instruments capable of detecting variations at that scale, calipers, micrometers, or some equivalent. Do we have evidence of such instruments in ancient Egypt? No. Nothing in the archaeological record suggests they had precision measuring tools. Maybe they used indirect methods, template matching, trial and error, create the vase, check it against a master template, grind away imperfections until it matches. Possible, but grinding granite to tolerances of 0 or 1 inches, that's extraordinarily difficult. Granite is hard, abrasion is slow. Removing material precisely, evenly, to such tight tolerances without modern tools, it strains credibility. But the vases exist. You can measure them yourself. The precision is real. Now let's talk about drill holes. In various locations in Egypt, Gobza, Abu Shir, Saqqara, there are stone blocks with holes drilled into them. Core drilling. A hollow tube pressed into the stone, cutting a circular hole and leaving a cylindrical core. Modern core drilling uses diamond-tipped or tungsten carbide drill bits, rotating at high speeds, pressed down with consistent force, cutting through stone efficiently. Ancient Egyptians, according to mainstream Egyptology, used copper tubes with sand as an abrasive. The tube rotates. Sand between the tube and the stone acts as the cutting agent. Slow, labour-intensive, but theoretically possible. But then you examine the drill cores. The cylindrical pieces of stone removed by the drilling process. And you notice something. Spiral grooves, regular, evenly spaced, running down the length of the core like threads on a screw. These grooves indicate the rate at which the drill advanced into the stone. Each rotation of the drill, it cuts slightly deeper, leaving a mark. The spacing of the grooves tells you how fast the drill was feeding into the stone. Engineer Christopher Dunn analysed these cores. He measured the groove spacing, and he calculated the feed rate, how far the drill advanced per rotation. His conclusion, some drill cores show feed rates of 0, 1 inches per revolution, 1/10 of an inch per rotation, cutting through granite. Modern diamond-tipped drills, cutting through granite, typically achieve feed rates of 0, 1 to 0. 0.02 inches per revolution, much slower. Even with hard modern drill bits and powerful motors, how did ancient copper drills with sand abrasive achieve feed rates 50 to 100 times faster than modern diamond drills? Dunn suggests several possibilities. Maybe the abrasive wasn't sand. Maybe it was something harder, corundum powder, diamond dust. But there's no evidence the Egyptians had access to such materials in quantity. Maybe the drilling technique was different. Maybe they used ultrasonic vibration, high-frequency oscillation that helps break apart the stone at the molecular level. Modern ultrasonic drilling exists. It's effective on hard materials, but there's no evidence the Egyptians had ultrasonic tools. No ancient drill bits sitting in museums. No technological artifacts suggesting such capability, yet the drill holes exist, the cores exist, the feed rates are measurable. Real numbers, real evidence. Mainstream Egyptology offers explanations. Maybe the grooves don't indicate feed rate. Maybe they're caused by variations in the hardness of the stone, or by the way the abrasive sand behaved, or by techniques we don't fully understand but that don't require advanced technology. Possible. But the precision remains troubling. The efficiency seems impossible with the tools we believe they had. Let's talk about saw marks. At various Egyptian sites there are stone blocks with saw cuts, long straight cuts through granite and basalt. Some cuts are partial, started but not completed. These partial cuts reveal how the sawing was done. The cuts are straight, remarkably straight, cutting through feet of hard stone without wavering, and they're deep. Some cuts go several feet into the block. Modern stone sawing uses diamond wire saws or large circular blades with diamond segments. The blade is cooled with water. It cuts slowly but precisely. Ancient Egyptians, we're told, used copper saws with sand abrasive, long copper blades, workers pulling back and forth, sand between the blade and the stone providing the cutting action. Again, theoretically possible. But when you examine the saw marks closely, there are issues. Some cuts show parallel striations, scratches running parallel to the cut. These striations are evenly spaced, as if the saw blade had teeth spaced about 1 millimeter apart. A copper blade with teeth? Copper is soft. Teeth would wear down rapidly cutting through granite. You'd need to replace the blade constantly, or use a material harder than copper. Bronze? Harder than copper, but still not ideal for cutting granite. Iron? Steel? Ancient Egyptian didn't have steel in the Old Kingdom period, yet the saw marks suggest a blade with regular teeth or cutting point. A blade that could maintain its shape through feet of cutting. A blade that could hold a straight line without bending or wandering. The evidence is difficult to reconcile with the known tools. Now let's go to Peru, to Ollantaytambo. Ollantaytambo is an Inca site in the Sacred Valley, stone terraces climbing the mountainside, a temple complex at the top, and massive blocks of red granite, each block weighing many tons, some over 50 tons. The granite came from a quarry on the other side of the valley, about 6 miles away, across the Urubamba Achir River, over mountainous terrain, at an elevation of around 9,000 feet. How were these stones moved? The Inca didn't have wheels, didn't have horses or oxen for draft animals. They had llamas, but llamas can't pull heavy loads. They're pack animals. They can carry maybe 70 pounds. A 50-ton block is 100,000 pounds. You'd need over 1,000 llamas just to equal the weight, and they can't be harnessed to pull together. So the answer must be human labour. Thousands of people. Ropes, levers, sledges, ingenuity. But the logistics are staggering. Let's do some math. A 50-ton block is 100,000 pounds. If each person can pull with a force of, say, 50 pounds, you'd need 2,000 people pulling simultaneously just to move the block on level ground. And that's assuming no friction, perfect coordination, and ideal conditions. In reality, friction is significant, stone sliding on stone, or stone on wooden rollers. Even with lubrication, water or clay, the friction would be substantial. You'd probably need 5,000 to 10,000 people to move one block. Now factor in the terrain. The route from the quarry to Ollantaytambo crosses a river, crosses hills, climbs elevation. Moving a 50-ton block uphill requires even more force. Gravity is working against you. And you need to move dozens of these blocks, each one a monumental effort, each one requiring thousands of people. Coordinated, working together. How do you coordinate 10,000 people pulling ropes? How do you ensure they all pull at the same time, with the same force? Modern construction projects use radios, signals, machinery. The Inca had what? Drums, vocal commands, visual signals. Maybe it's possible. Humans are ingenious. Given enough people and enough time, maybe you can move mountains. But then you look at the blocks at Ollantaytambo and you notice something else. They're fitted together using polygonal masonry. Each block has multiple sides, 6 sides, 8 sides, 12 sides. And each face is shaped to fit perfectly against the neighbouring blocks. No mortar, no gaps. The fit is so tight you can't slide a knife blade between the stones. To create this, you need to shape each block precisely. Each face has to match its neighbour. One error and the block doesn't fit. You'd have to start over or adjust every neighbouring block. How many attempts does it take to get it right? How many blocks were discarded because they didn't fit? Or did they never make mistakes? Did they have a technique, a method of precise measurement and cutting that ensured each block fit perfectly the first time? We don't know. The Inca left no written records explaining their construction techniques. The Spanish conquistadors who encountered the Inca didn't document the methods. By the time archaeologists arrived, the knowledge was lost, but the stones remain fitted, precise. Impossible to replicate easily even with modern tools. Let's talk about Coral Castle. Coral Castle is in Florida, built by a single man, Edward Leeds Calnin, between 1923 and 1951. It's a structure made of massive coral blocks. Some blocks weigh over 30 tons. The tallest stone weighs an estimated 28 tons and stands 25 feet tall. Leeds Calnin built this alone. He stood 5 feet tall, weighed 100 pounds, and he moved multi-ton blocks by himself at night. In secret, he didn't allow anyone to watch him work. When asked how he did it, he gave cryptic answers. He understood the secrets of the pyramids, he said. He knew how the ancients moved massive stones. He used magnetism, leverage, lost knowledge. After his death, researchers examined the site. They found simple tools, tripods made from telephone poles, chain hoists, wheels and axles, basic mechanical advantage devices. Could these tools, operated by one small man, move 30-ton blocks? Mechanically, yes. Leverage and pulleys can multiply force. If you have the right setup, one person can move enormous weights, but it's slow, difficult. Requires perfect technique. Leeds Calnin worked for decades, moved stones inch by inch, slowly assembling his castle. It proves that moving massive stones is possible without modern machinery. But it also shows how slow and labour-intensive it is. Now, imagine scaling this up. Not one man moving one stone over years, but thousands of stones, moved miles, lifted into precise positions in a fraction of the time. The ancient builders had labour, lots of labour. But did they have time? Did they have centuries to build each structure, or did they build faster than we think? Some pyramids, according to conventional dating, were built in a pharaoh's lifetime, 20 to 30 years. Millions of stone blocks. That requires placing one block every few minutes, working around the clock. Can that be done with ramps and ropes and thousands of workers? Maybe. But the organisational complexity is immense, the logistics staggering, and the precision. Always the precision. Blocks fitted perfectly, edges aligned, tolerances tighter than we expect from ancient civilizations. Let's talk about acoustic levitation. It sounds like science fiction. Using sound to lift objects, but it's real. Modern labs have demonstrated acoustic levitation. High-frequency sound waves create pressure nodes. Objects can be suspended in these nodes, lifted, moved. The effect is limited. Current technology can levitate small objects, droplets, particles, nothing approaching multi-ton stones. But the principle works. Sound can move matter. If you could scale it up, if you could generate the right frequencies at the right power, could you lift stones? There are legends. Tibetan monks describing how lamas levitated stones using sound. Drums, horns, trumpets, creating resonant frequencies that made the stones float. Unverified, anecdotal. No modern demonstration of this effect at the scale required. But what if there's something to it? What if ancient builders understood acoustic principles we've lost? What if they could generate frequencies, create resonances, make stones easier to move? Speculative. Highly speculative. But the precision, the scale, the difficulty of moving these stones with known methods. It makes you wonder, maybe they had techniques we've lost. Maybe they understood physics in ways we don't. Maybe the knowledge vanished when the builders died without passing it on. Or maybe they were just better than we give them credit for, more patient, more skilled, more willing to spend decades perfecting a single structure. The truth is, we don't know. We have the stones, we have the measurements, we have the evidence of precision that challenges our understanding. But we don't have the tools, we don't have the blueprints, we don't have the instruction manuals. The builders are gone. Their techniques are lost. And we're left standing in front of these monuments, these impossible structures, trying to reverse engineer how it was done. Picture yourself at Sahara, running your hand along a drill hole in a granite block, feeling the smooth spiral grooves, trying to imagine the drill that made them, the tool that cut through granite like butter. Picture yourself at Ollantay Tambo, standing between two massive blocks, unable to fit a piece of paper in the gap, staring up at 50-ton stones fitted together like a jigsaw puzzle. Picture yourself in the Cairo museum basement, measuring a granite vase with calipers, writing down the numbers, 1,000th of an inch, precision that shouldn't exist. The stones don't explain themselves, they just sit, silent, precise, waiting for us to understand. Let these thoughts drift. The precision remains. The mystery endures. The stones will keep their secrets a little longer. Tomorrow, when you wake, the drill holes will still be there. The vases will still be precise. The polygonal walls will still fit perfectly. And we'll still be wondering, how? But the stones are only part of the mystery. Because it's not just that they built with precision, it's that they built with purpose. Every angle calculated, every stone aligned. To what? To the stars, to the sun, to patterns in the sky. The precisions served alignment, and the alignments tell their own story. Sleep now. The stones will wait. They've been waiting for thousands of years. They can wait one more night. Good night, engineers. Your precision endures. Stand at Giza. It's the spring equinox. Dawn. The desert is quiet, Cool. The sky is lightening from black to deep blue to pale orange on the eastern horizon. And before you, rising from the plateau, 3 pyramids. The Great Pyramid of Khufu, the Pyramid of Khafra, the Pyramid of Menkaure. Massive, ancient, silent. But they're not random. They're not arbitrarily placed. If you look down from above, if you could see the plateau from the air, you'd notice something. The 3 pyramids are positioned to mirror the stars of Orion's belt. Al-Nitak, Al-Nilam, Mintaka, 3 stars in a diagonal line. And below them, the 3 pyramids in a diagonal line, the same pattern, the same relative positions. Even the offset, Menkaure is slightly east of the line formed by the other 2, matches the offset of Mintaka in the constellation. The correlation was proposed by researcher Robert Bauval in the 1980s, the Orion correlation theory. He suggested the pyramids were deliberately positioned to match Orion's belt, not as it appears today, but as it appeared around 10,500 BC, when Orion was at its lowest point in the precessional cycle. Controversial, most Egyptologists reject it. The pyramids were built around 2,500 BC, they say, not 10,500 BC. The correlation is coincidental or exaggerated, but the alignment is there, measurable, real. Whether it was intentional, whether it references an earlier time, whether it means what Bauval suggests, those are open questions. But the pattern exists, and it's not just Giza. All over the world, ancient structures are aligned to the stars, to the sun, to the moon, to cardinal directions, to each other. This isn't decorative. This isn't random. The builders went to extraordinary effort to achieve these alignments. They measured, they calculated, they positioned their monuments with precision. Why? Let's start simple. Solar alignments. Many ancient structures align to the solstices or equinoxes, the longest day, the shortest day, the days when day and night are equal. Stonehenge, the famous stone circle in England. On the summer solstice, the sun rises directly over the heel stone when viewed from the centre of the circle. The alignment is precise, deliberate. Thousands of people gather at Stonehenge every year on the summer solstice to witness this moment. The sun cresting the horizon, the light streaming through the stones. Why build this? To mark the seasons, obviously. The solstice indicates the turning of the year. Longest day means summer, important for agriculture, plant, harvest, survive, but Stonehenge is more than a calendar. It's massive. It required hundreds of workers, years of effort, stones transported from over 100 miles away, blue stones from Wales, sarsen stones from the Marlborough Downs, each stone weighing tons, dragged, lifted, positioned. You don't need a structure this large just to mark the solstice. A single standing stone would suffice. 2 stones. A simple alignment. Why build circles? Why build trilithons? 2 vertical stones with a horizontal lintel across the top. Why the complexity? Because it's not just about marking time. It's about something else, something sacred. Something significant enough to justify monumental effort. Now go to Ireland. Newgrange. We discussed it earlier. The passage tomb where light enters the chamber on the winter solstice. The passage is 60 feet long, narrow, dark. And above the entrance there's a small opening, the roof box, precisely positioned to allow sunlight to enter only at a specific time, only on the winter solstice. Only for about 17 minutes as the sun rises, the light travels down the passage, illuminates the inner chamber, then fades. 5,000 years later, it still works. The alignment is still accurate. The light still enters. Still marks the shortest day. The builders of Newgrange had to understand the solar year. Had to know exactly where the sun would rise on the winter solstice. Had to calculate the angle, the height, the orientation. They had to care deeply about this moment, this alignment, this connection between the earth and the sun. Now go to Mexico. Chichen Itza, the pyramid of Kukulkan. On the spring and autumn equinoxes, as the sun sets, shadows fall on the northern staircase of the pyramid. The shadows create the illusion of a serpent, a snake of light and dark undulating down the pyramid, descending from the heavens to the earth. The effect lasts a few hours, then it's gone, until the next equinox. This requires precise architecture, the angle of the steps, the orientation of the pyramid, the timing of the sun's movement, all calculated to create this specific effect on these specific days. Why? To mark the equinox, yes, but also to create a spectacle, a moment of wonder, a connection between the sky and the structure, between the cosmic and the earthly. Solar alignments make sense. The sun is critical to life, to agriculture, to survival. Tracking the sun's movement through the year is practical, necessary, but then you have lunar alignments, and those are more complex. The moon's cycle is complicated. It rises and sets at different points on the horizon throughout the month. The angle changes, and over a longer cycle, 6 years, the range of rising and setting points shifts. The major standstill and minor standstill. The moon's orbit precesses, creating a complex pattern. To track this, you need long-term observation, decades, generations. You need to notice patterns that take longer than a human lifetime to complete. Yet some ancient structures align to lunar standstills. Stonehenge has lunar alignments as well as solar. Certain stones mark the moonrise at the major standstill, Chaco Canyon in New Mexico. The ancestral Puebloans built structures aligned to lunar standstills. They track the moon with precision over decades. Why? The moon doesn't directly affect planting schedules the way the sun does. Lunar cycles influence tides, certainly, but tracking an 6-year cycle? That's dedication to astronomy for its own sake, or for purposes we don't fully understand. Now let's talk about stellar alignments, specifically alignments to specific stars or constellations. The pyramids at Giza, Orion's belt. We already mentioned it. But it's not just the ground plan. The shafts inside the Great Pyramid also align to stars. The so-called air shafts, narrow channels running from the King's Chamber and Queen's Chamber toward the outer surface of the pyramid. They're not for ventilation. They're too narrow, too precisely angled. Researchers have calculated that around 2500 BC, these shafts pointed to specific stars. The southern shaft from the King's Chamber aligned with Alnitak in Orion. The northern shaft aligned with the star Thuban in Draco, which was the pole star at the time. The shafts don't reach the surface. They stop short. They're not functional passages. They're symbolic or astronomical. Aligning the interior of the pyramid to the stars. Why? Maybe religious. The ancient Egyptians associated Orion with Osiris, the god of the afterlife. The pharaoh's soul would travel to the stars, Join Osiris. Live eternally among the celestial realm, so the alignments are symbolic, a pathway to the stars, a connection between the earthly tomb and the heavenly destination. That's the conventional explanation, and it makes sense. Religion, symbolism, the cosmos as sacred. But then you find similar alignments in other cultures with different religions, different myths, yet the same astronomical obsession. Angkor Wat in Cambodia. The temple complex aligns to the spring equinox. On that day, the sun rises directly over the central tower when viewed from the entrance. Precise, deliberate. But more than that, the layout of the temple, the positions of towers and structures, corresponds to the constellation Draco. Not as Draco appears today, as it appeared around 10,500 BC. Why would a 12th century temple encode star positions from 10,000 years earlier? One possibility, the builders were using ancient star charts. Maps passed down through generations, sacred diagrams showing the sky as it appeared in a distant past. And they considered those ancient positions sacred, significant, worth preserving in stone. Now let's talk about cardinal alignments, structures aligned precisely to the four directions: north, south, east, west. The Great Pyramid at Giza is aligned to the cardinal directions with incredible precision. The sides of the pyramid face true north, south, east, and west. The error is less than 1/15 of 1 degree. That's astonishingly accurate. To achieve this, the builders needed a method of determining true north, not magnetic north. The magnetic North Pole moves, but true north, the rotational axis of the Earth, the point around which the stars appear to rotate. How do you find true north without a compass, without GPS, without modern instruments? You watch the stars, find the point in the sky that doesn't move, the celestial pole. In the northern hemisphere, that's near Polaris today. But 4,500 years ago, when the pyramids were built, Polaris wasn't the pole star. Thuban in Draco was closer to the pole, but even Thuban wasn't exactly at the pole. There's always a slight offset, so you observe multiple stars. Track their movements, find the center point around which they rotate. That's true north. It requires patience, clear nights, precise observation, but it can be done. And the Egyptians did it, with extraordinary accuracy. Other cultures did the same. Teotihuacan in Mexico, the Pyramid of the Sun. The entire city is laid out on a grid aligned to the cardinal directions, not perfectly. There's a slight offset, but close, deliberate. The ancestral Pueblones at Chaco Canyon, their great houses aligned to cardinal directions and to solar and lunar events. The entire complex is a cosmic observatory built in stone. Now let's talk about something stranger. The 19.5-degree mystery. 19.5 degrees latitude, north and south. This latitude appears repeatedly in contexts both ancient and modern, in ways that seem too consistent to be coincidental. The Great Pyramid's King's Chamber has an angle in its construction that relates to 19. 5 degrees. Teotihuacan's Pyramid of the Sun sits near 19. 5 degrees north latitude. Many ancient sacred sites cluster around this latitude, but it's not just Earth. On other planets, significant features appear at 19, 5 degrees latitude. The Great Red Spot on Jupiter, Olympus Mons on Mars, the largest shield volcano in the solar system, the Great Dark Spot on Neptune. Why this latitude? What's special about 19? 5 degrees? Mathematically, it relates to tetrahedrons. A tetrahedron inscribed in a sphere, one point at the pole, The other 3 points form a triangle at 19. 5 degrees latitude, it's a geometric relationship, sacred geometry. Some researchers suggest it represents energy points, upwelling, places where internal planetary energy manifests. Speculative, highly speculative, but the pattern is there. The number appears repeatedly. Now let's talk about ley lines. The idea that ancient sites align with each other across vast distances. In the 1920s, Alfred Watkins in England noticed that ancient sites, standing stones, stone circles, hill forts, churches built on older pagan sites, often lined up. If you drew a line on a map connecting them, multiple sites would fall on the same line. He called these ley lines. Watkins thought they were ancient trackways, roads, paths of trade or travel. Later enthusiasts suggested they were lines of energy, earth energy, sacred geometry, places of power. Mainstream archaeology is skeptical. With enough sites on a map, some will align by chance, statistical clustering, pattern seeking in randomness. But some alignments are striking, multiple significant sites, aligned over hundreds of miles. The mathematical probability of chance. Alignment drops. And it's not just England. Similar patterns appear globally. Sacred sites in alignment, too many, too precise, to be entirely coincidental. What were the builders doing? Marking something, creating a network, connecting sites for purposes we don't understand? Or is it confirmation bias? We notice the alignments that exist and ignore the thousands of sites that don't align. We see patterns because we want to see them. Difficult to say, but the obsession with alignment is undeniable. Cultures worldwide built structures oriented to astronomical events, cardinal directions, and sometimes to each other. They cared about alignment deeply. It mattered enough to measure, to calculate, to build with precision. Let's think about magnetic alignments. Earth has a magnetic field. Certain locations have magnetic anomalies, variations in field strength, places where compasses don't point true north, where the field is stronger or weaker. Some ancient sacred sites correlate with magnetic anomalies. Stonehenge sits on a magnetic anomaly. So do some sites in Chaco Canyon. So do certain locations in Peru. Coincidence? Or did ancient peoples sense the magnetic field, feel it somehow? Choose sites based on geomagnetic properties. Modern humans can't consciously sense magnetic fields, but some animals can. Birds use it for navigation. Certain bacteria orient to magnetic fields. Maybe ancient humans had heightened sensitivity. Or maybe they had instruments we don't know about. Or maybe it's coincidence. We're noticing correlation where none exists. But the alignments persist. The precision is real. The effort is undeniable. Picture the builders, or standing on the plateau at Giza, looking up at Orion, measuring angles, calculating positions, positioning the pyramids to mirror the stars. Picture the astronomers at Stonehenge, watching the sun for years, tracking the solstices, marking the points where the sun rises and sets, erecting stones to frame those moments. Picture the priests at Angkor Wat, consulting ancient star charts, diagrams showing the sky as it appeared thousands of years before they were born. Encoding those positions into the temple layout, preserving the sacred geometry. They weren't just building monuments, they were building messages, preserving information, connecting the earthly to the celestial. But messages about what? Information about what? Maybe about time, about cycles, about the long patterns in the sky, that repeat over millennia. The precession, the great year, the 26,000-year wobble of Earth's axis. Maybe they were marking something, warning about something, preserving knowledge about cycles of catastrophe, times when the earth and sky align in dangerous ways. Let these thoughts drift. The stars turn above. The monuments below remain aligned, pointing, marking, waiting. The alignments are not random. They're intentional, precise, important enough to justify generations of effort. And they're trying to tell us something. If only we could remember the language. If only we could read the message written in stone and starlight. Sleep now. The stars will keep turning. The monuments will keep pointing. The alignments will endure. And maybe one day we'll understand what they're trying to say. Good night, astronomers. Your monuments still point to the heavens. There's a pattern hidden in mythology, a pattern that appears across cultures, across continents, across time. It's not obvious at first. The stories seem different. Different gods, different details, different names. But when you step back, when you look at the structure beneath the narrative, when you compare the myths from around the world, you see it. The world has ended before. Multiple times, and it will end again. This isn't metaphor. This isn't religious allegory about spiritual death and rebirth. This is cosmology, a description of how the universe works, how the earth works, how time itself works. Cyclical catastrophe, destruction and renewal, ages of the world rising and falling like tides. Let's start in India. With the Yugas, Hindu cosmology describes time as operating in vast cycles. 4 Yugas, 4 ages that repeat endlessly: Satya Yuga, Treta Yuga, Dvapara Yuga, Kali Yuga. Satya Yuga is the golden age. Humanity is virtuous. Lives are long. The world is abundant. This age lasts 728 million years. Then comes Treta Yuga. Virtue declines slightly, human lifespans shorten. This age lasts 296 million years. Dvapara Yuga, further decline, more suffering, more conflict, 864,000 years. Kali Yuga, the Dark Age, the age of quarrel and hypocrisy. Virtue almost vanished, lifespans short, suffering widespread. This age lasts 432,000 years. We're in Kali Yuga now. According to Hindu tradition, the Dark Age, it began around 3102 BC. We're about 5,000 years into a 432,000 year cycle. At the end of Kali Yuga, the world is destroyed. Fire, flood, cosmic dissolution, then it's reborn. Satya Yuga begins again. The cycle continues. 4 ages: destruction, rebirth, eternal recurrence. Now go to Mesoamerica, the Aztec cosmology. The Aztecs believed in 5 suns, 5 worlds, 5 ages of creation, each one destroyed by catastrophe. The first sun, destroyed by jaguars. The gods sent jaguars to devour humanity. The age ended in violence and predation. The second sun, destroyed by wind, hurricanes, massive storms that tore the world apart. The few survivors became monkeys. The third sun, destroyed by rain of fire, volcanic eruptions, burning ash falling from the sky. The survivors became birds. The fourth sun, destroyed by flood, water covering the earth, drowning the world. The survivors became fish. The fifth sun, the current age, the age we're living in now. And it too will end, by earthquake, according to the prophecy. The earth will shake itself apart, mountains will fall, cities will crumble, and humanity will face extinction again. 5 ages, 4 destructions already past, 1 destruction yet to come. Now go to the American Southwest, the Hopi people. Hopi tradition describes 3 previous worlds, each one destroyed when humanity became corrupt, when people forgot the sacred way, when they stopped living in balance with creation. The first world was destroyed by fire, volcanoes, burning, the earth itself erupting. The second world was destroyed by ice, freezing, the world covered in snow and ice, everything frozen. The third world was destroyed by water, flood, the great deluge. Only a few survived, climbing to the highest mountains, floating in sealed vessels. We're in the fourth world now, and it too will end. The Hopi prophecies describe signs, warnings, events that indicate the fourth world is approaching its end, and when it ends, a fifth world will begin. For those who remember, for those who maintain balance, 3 destructions. One more coming. The pattern repeats. Now go to Scandinavia, Norse mythology, Ragnarok, the twilight of the gods, the end of the world. The prophecy is specific. Winter will come. Fimble winter. 3 winters with no summer in between. The sun will fail. Snow and ice will cover the world. Darkness and cold. Then the earth will shake. Mountains will fall. The world serpent will rise from the ocean. The wolf Fenrir will break free. The giants will march on Asgard. Fire and ice. Destruction. The gods themselves will die. Odin, Thor, Loki. The cosmic order will collapse. And then, rebirth. The earth will rise from the ocean. Green, fertile, a new world. 2 human survivors, Lif and Lifthrasir, will emerge from hiding. They'll repopulate the earth. A few gods will survive and rebuild. End, beginning. The cycle continues. Do you see the pattern now? Different cultures, different imagery, but the same structure. Ages of the world. Destruction by fire, ice, flood, earthquake, a few survivors, rebirth, the cycle repeating. Why do so many cultures tell this same story? Why do myths from India to Mexico to Scandinavia to the American Southwest describe cyclical catastrophes? Because they experience them, because the catastrophes are real, because the memory is preserved in mythology, and because they're trying to warn us. It will happen again. Let's look at the scientific evidence, because the myths aren't just stories, they're supported by geology, by climate science, by archaeology. We've already discussed the flood. The catastrophic sea level rise around 11,600 years ago. The drowning of coastlands, the end of the Ice Age, real, documented, geological fact. But that wasn't the only catastrophe. There were others. And there's a pattern to them. The Younger Dryas impact hypothesis. Around 12,800 years ago, the Earth was warming. The Ice Age was ending. The ice sheets were melting. Climate was stabilizing. Then something happened. Suddenly, within decades, possibly within years, the temperature dropped, plunged. The world returned to near glacial conditions. This cold period lasted about 300 years. Then, just as suddenly, it ended. The temperature spiked upward. The ice melted rapidly. Sea levels rose. This period is called the Younger Dryas. Named after a flower, Dryas octopetala, that appears in the geological record during this cold interval. What caused it? For years, scientists debated. Maybe changes in ocean currents, maybe volcanic activity, maybe variations in solar output. But in recent years, evidence has accumulated for another explanation. Impact. Around 12,800 years ago, Earth may have been struck by fragments of a comet or asteroid. Not a single large impact like the one that killed the dinosaurs, but multiple impacts. an airburst or airbursts, explosions in the atmosphere, shock waves, fires, ejected material. The evidence, a layer of sediment dating to 12,800 years ago that contains unusual materials, nanodiamonds, formed under extreme pressure, iridium, an element rare on Earth but common in asteroids. Spherules, tiny glass beads created by intense heat, charcoal layers indicating massive wildfires. This layer appears across North America, Europe, the Middle East, a global event, the Carolina Bays. Mysterious elliptical depressions scattered across the southeastern United States, hundreds of thousands of them, oriented in the same direction, as if created by a massive airburst that showered the region with secondary impacts. If this hypothesis is correct, and it remains debated, then Earth was struck by cosmic debris around 12,800 years ago. The impacts triggered wildfires across continents, ejected material into the atmosphere, blocking sunlight. The temperature dropped. Ice Age conditions returned briefly, then the debris settled. The sun returned. The warming resumed rapidly, but the damage was done. Megafauna extinctions, woolly mammoths, saber-toothed cats, giant sloths, gone. Possibly from the impact, possibly from the climate whiplash, possibly from overhunting by humans facing desperate conditions, and human populations disrupted, displaced. The Clovis culture in North America, characterized by distinctive stone tools, disappears from the archaeological record shortly after the Younger Dryas begins, replaced by other cultures, other tool traditions, catastrophe, real catastrophe. Recorded in geology, in paleoclimatology, in archaeology, and it's not the only one. Go back further, 74,000 years ago, Mount Toba, the supervolcano in Indonesia. We discussed it in the sample script. The eruption that nearly extinguished humanity, the volcanic winter, ash and sulfur dioxide in the atmosphere, temperatures dropping globally, plants dying, ecosystems collapsing, human populations crashing to a few thousand individuals. Genetic bottleneck, evidence written in our DNA. We almost didn't make it. Catastrophe. Again. Are you noticing a pattern? Not just that catastrophes happen, but when they happen. Toba, 74,000 years ago. Younger Dryas impact, 12,800 years ago. Younger Dryas, end or rapid warming, surf floods, 11,600 years ago. The interval between Younger Dryas and now, about 12,000 years. Some researchers have noticed this, a roughly 12,000 year pattern. Catastrophic events occurring at intervals, not perfectly regular, but clustered, cyclical. Ice core data supports this. When scientists drill into ice sheets in Greenland and Antarctica, they extract cores. Layers of ice representing thousands of years of snowfall. Each layer contains trapped air bubbles, atmospheric samples from the past, dust, volcanic ash, chemical signatures. When you analyse these cores, you find evidence of sudden climate shifts, not gradual warming or cooling, but abrupt changes, temperature jumping or dropping by degrees within decades, sometimes within years, and these abrupt shifts happen repeatedly. At intervals, roughly every 12,000 years, though the pattern isn't perfect. What causes this? What could trigger global catastrophes at roughly regular intervals? Several theories. Let's explore them. Solar cycles. The sun isn't constant. Solar output varies. Sunspot cycles. Every 11 years, solar activity peaks and declines. But there are longer cycles too. Grand solar minimums. periods when solar activity drops significantly. The Maunder minimum in the 17th century, the Dalton minimum in the 19th century. These minimums correlate with cooler global temperatures, but there might be even longer cycles lasting thousands of years. Cycles that affect Earth's climate, magnetic field, and cosmic ray exposure. Some researchers propose that the Sun undergoes periodic micronovas, not full supernovas. The Sun isn't massive enough for that, but smaller eruptions. Coronal mass ejections on a scale far beyond anything we've experienced in recorded history. A shell of plasma expelled from the Sun, sweeping through the solar system, impacting Earth. The effects would be catastrophic. Atmospheric stripping, magnetic field disruption, fires from the energy pulse, climate chaos from the electromagnetic effects. Speculative, yes, but there's evidence that other stars do this. Solar-type stars exhibiting sudden brightening, outbursts. If it happens to them, could it happen to our Sun? Magnetic field reversals. Earth's magnetic field isn't stable. It flips. North becomes south, south becomes north. We know this from paleomagnetic studies. Rocks contain magnetic minerals that align with the field when the rock forms. By studying ancient rocks, we can trace how the magnetic field has changed over millions of years, and it's flipped many times. The last full reversal was about 780,000 years ago. But there have been excursions. Temporary weakening and shifting of the field. Some researchers suggest these excursions happen roughly every 12,000 years. When the magnetic field weakens, Earth is more vulnerable to cosmic rays and solar radiation. The field normally shields us, deflects charged particles. When it weakens, more radiation reaches the surface, affecting climate, affecting life. Could magnetic excursions trigger catastrophes? Possibly. The mechanisms aren't fully understood, but the correlation is intriguing. Cosmic cycles, Earth moves through space. The solar system moves through the galaxy. We orbit the Milky Way center every 230 million years. As we orbit, we pass through different regions, different densities of interstellar material, different cosmic ray environments. Some researchers suggest we pass through a galactic sheet of debris roughly every 12,000 years. A region with higher concentrations of comets, asteroids, dust. When Earth passes through, impacts become more likely. The Younger Dryas impact could be evidence of this. Crustal displacement. This is the most controversial. The idea that Earth's crust can shift suddenly relative to the interior, like the skin of an orange sliding over the fruit. Pole shift. Not magnetic pole shift, physical pole shift. Continents moving thousands of miles in a short time. If this happened, the effects would be catastrophic. Earthquakes, volcanism, tidal waves, climate zones shifting instantly, ice caps forming in new locations, coastlines changing. Charles Hapgood proposed this in the 1950s. He suggested it could explain why Antarctica has ice. Maybe it wasn't always at the pole. Maybe it shifted there relatively recently. Maybe maps showing Antarctica without ice are from before the shift. Mainstream geology rejects this. Plate tectonics explains crustal movement, but it's slow, centimetres per year, not sudden catastrophic shifts. But Hapgood had a supporter, Albert Einstein. Einstein wrote foreword to Hapgood's book. He found the theory intriguing, possible, though he didn't fully endorse it. Could crustal displacement happen? The mechanisms are unclear, but if it did, it would fit the pattern. cyclical catastrophes. Earth reorganizing itself periodically. Now let's connect this back to the myths, to the monuments, to the astronomical alignments. The ancient peoples experienced catastrophes, fire, ice, flood. They survived. Barely. And they knew it could happen again, so they preserved the knowledge, encoded it in myths, built it into monuments, aligned structures to the stars to mark the cycles, the precession of the equinoxes, the 26,000-year wobble of Earth's axis. Maybe this cycle correlates with the catastrophes. Maybe at certain points in the precessional cycle, Earth is more vulnerable, more exposed to cosmic impacts, more likely to experience magnetic field disruptions, more prone to climate whiplash. The monuments mark the cycle. The alignments preserve the data. When Orion is at its lowest point in the sky, around 10,500 BC, that's a dangerous time. A time when catastrophe is more likely. And we're approaching that point again, not 10,500 BC, but the opposite end of the cycle. The precession is bringing us back toward a similar configuration. Is another catastrophe coming? Are we in the danger zone? The myths say yes. The fourth world is ending, say the Hopi. Kali Yuga continues its dark age, say the Hindus. The fifth sun will end, say the Aztecs. Ragnarok approaches, say the Norse. And the monuments, they're still pointing. Still marking, still warning. This is why they built in stone. Why they encoded astronomical knowledge. Why they obsessed over alignments. They were creating a message that could survive the catastrophe, survive the forgetting, survive thousands of years. A message to us, to their descendants, to whoever would come after. Beware. It happened before. It will happen again. Watch the stars. Track the cycles. Remember, picture the survivors standing in the aftermath, watching the floods recede, watching the fires burn out, counting the dead, burying the lost, and deciding, we must remember this. We must warn those who come after. How do we do that? How do we send a message across thousands of years? We build in stone. We align to the stars. We encode the knowledge in myths, in monuments, in sacred geometry. We make it too big to forget, too precise to ignore, and we hope. Hope that someday someone will understand. Someone will read the message. Someone will remember before it's too late. Let these thoughts settle as sleep approaches. The monuments stand. The myths persist. The warnings echo across millennia. Are they right? Is another catastrophe coming? We don't know. The science is still uncertain. The patterns suggestive but not conclusive. But the ancients were certain. They experienced it. They remembered. They warned. Maybe we should listen. Maybe we should prepare. Maybe we should remember what they tried so hard to preserve. The stones don't lie. The ice cores don't lie. The genetic bottlenecks don't lie. Catastrophe is not a question of if, only when. Sleep now. The cycle continues. The stars turn. The earth spins. And somewhere in the patterns, the answer waits. They survived the fire. They survived the flood. They built monuments to survive time itself. And in those monuments, they left warnings for us. Good night, survivors. Your warnings endure. Close your eyes and picture a continent, not one you've visited, not one you'll ever set foot on. A continent the size of the United States and Mexico combined, 14 million square kilometers, vast, remote. Hostile, Antarctica. Right now, as you read this, Antarctica is covered in ice. Not a thin layer, not seasonal snow. Ice sheets averaging 1 mile thick, in some places over 2 miles thick. That's 10,000 feet of ice, pressing down on the land with unimaginable weight, covering everything, hiding everything. 98% of Antarctica is buried beneath this ice. Only 2% of the land is visible. Mountain peaks poking through, rocky coastlines at the edges. The rest, unknown, unexplored, inaccessible without drilling, radar, and sophisticated equipment. What's under there? Under 2 miles of ice covering an entire continent, we assume rock. Bare rock, mountains, valleys, ancient geology, nothing of interest, nothing human, because humans never lived in Antarctica. How could they? It's been frozen for millions of years, uninhabitable, lifeless except at the margins. But what if that assumption is wrong? What if Antarctica wasn't always frozen? What if there was a time, not millions of years ago, but thousands of years ago, when parts of Antarctica were ice-free, temperate, habitable, green? What if people lived there? Let's start with the geology. The timeline. Antarctica wasn't always at the South Pole. This isn't controversial. Continental drift is well-established science. Continents move, slowly, over millions of years. Antarctica was once part of Gondwana, the ancient supercontinent. It was connected to South America, Africa, India, and Australia. It was warmer, it had forests, dinosaurs lived there. But that was hundreds of millions of years ago. By the time humans evolved, Antarctica had drifted south, positioned over the pole, cold, accumulating ice. The current ice sheets began forming around 34 million years ago. The continent gradually froze. By a few million years ago, Antarctica was essentially as frozen as it is today. That's the standard narrative. Antarctica has been a frozen wasteland throughout all of human history. No civilization could have existed there. But recent research suggests a more nuanced picture. Ice doesn't accumulate evenly. It builds up over time, yes, but climate fluctuates. During warmer periods, ice melts. During colder periods, it accumulates. The ice sheets aren't static. They advance and retreat. Core samples drilled from Antarctic ice show layers. Each layer represents a year of snowfall. By analysing these layers, scientists can reconstruct climate history going back hundreds of thousands of years. And what they've found is that Antarctica has experienced warming periods, not full deglaciation, but partial melting, especially around the coasts. Especially in West Antarctica, which is lower in elevation and more vulnerable to warming. During the last interglacial period, around 130,000 years ago, global temperatures were slightly warmer than today. Sea levels were higher, and some evidence suggests that parts of West Antarctica may have been ice-free or had significantly reduced ice coverage. That's too early for human civilization as we know it, but it establishes a principle. Antarctica's ice isn't permanent, it changes. Now fast forward. To the end of the Ice Age, around 12,000 years ago, global temperatures rose rapidly. Ice sheets in North America and Europe melted, sea levels rose, climate shifted. What happened to Antarctica? The conventional answer, not much. Antarctica is isolated. The circumpolar current keeps warm water away from the continent. The ice remains stable, but some researchers question this. They point to evidence of climate variability, evidence that coastal regions of Antarctica might have experienced warming, might have had reduced ice coverage, might have been marginally habitable. Not the interior. The high plateau would have remained frozen, but the coasts, the lower elevations, possibly. We're talking about a window. A brief period, maybe a few thousand years, when parts of Antarctica were accessible, not tropical, not comfortable, but livable, perhaps comparable to modern Iceland or southern Alaska. A climate window when people could have settled there, fished the coasts, lived in sheltered bays, maybe even built structures. Then the climate shifted again, or the ice advanced, or something else happened. And whatever was there was covered, buried, frozen in place. Now let's revisit the maps. The Piri Reis map, the Oronteus Phineus map. We discussed them earlier. These maps show Antarctica, not as a frozen wasteland, but with coastlines, with geographic features, with rivers and mountains. The Piri Reis map, when analysed by modern cartographers and compared to seismic surveys, shows remarkable accuracy. The shape of the coastline matches the actual land beneath the ice. Not perfectly. There are distortions inherent in the projection and copying process, but the general features correspond. The Oronteus Phineus map from 1531 shows even more detail. It depicts Antarctica as two separate land masses with a waterway between them. For centuries, this was thought to be complete fabrication. Antarctica is one continent, right? But then ice-penetrating radar revealed the truth. Beneath the ice, Antarctica is indeed two land masses, East Antarctica and West Antarctica, separated by a deep trench. If the ice were removed, water would fill this trench. The continent would appear as two large islands. Exactly as the Oronteus Phineus map depicts it. How did a 16th century cartographer know this? He didn't have radar, didn't have satellites, didn't have any way to see through miles of ice, unless he was copying from much older maps. Maps made when the ice wasn't there. Maps made when someone could actually see the land. Who made those maps? When? How? If parts of Antarctica were ice-free or ice-reduced thousands of years ago, someone could have sailed the coasts, surveyed them, mapped them, and those maps survived, copied through generations, eventually reaching Piri Reis and Phineus, who incorporated them into their world maps without fully understanding what they were copying. It's speculative, but it fits the evidence. Now let's talk about Operation High Jump. In 1946, shortly after World War II ended, the United States Navy launched a massive expedition to Antarctica, Operation High Jump, led by Admiral Richard Byrd. The official purpose to establish a research base, to train personnel in polar conditions, to test equipment in extreme cold. But the scale was unusual. This wasn't a small research expedition. It was a military operation. 13 ships, 4,000 personnel, aircraft, sophisticated equipment. They spent several months in Antarctica, conducting flights, mapping, photographing the coastline, and then they left abruptly. Earlier than planned. The operation was supposed to last 8 months. It lasted 4. What happened? The official explanation: weather, ice conditions, logistical challenges. They accomplished their objectives and came home. But rumours persisted. Stories about what they found, about strange geographical features, about Admiral Byrd making cryptic comments in interviews afterward, about discoveries that weren't made public. most of this is probably myth. Conspiracy theories. People seeing mystery where there's only mundane military logistics. But Operation High Jump did produce something valuable. Thousands of aerial photographs, detailed images of Antarctic coastlines and interior regions. Some of these photos have been analysed by researchers looking for anomalies, for features that might indicate human activity. Nothing conclusive has been found, but the photos are limited, low resolution by modern standards, covering only a fraction of the continent, and most of Antarctica remains unmapped at high resolution. Satellites have surveyed it, yes, but radar penetration is limited. We can see the surface ice. We can detect major features beneath, mountains, trenches, lakes, but fine details, structures the size of buildings, those would be invisible under 2 miles of ice. Let's talk about Lake Vostok. In the 1970s, Soviet researchers were drilling ice cores in Antarctica. Deep drilling, trying to retrieve ice samples from thousands of years ago. At a place called Vostok Station, they drilled down 11,000 feet, over 2 miles, and they encountered something unexpected. Water. Not frozen water, liquid water, beneath the ice. Further investigation revealed a massive subglacial lake, Lake Vostok, one of the largest lakes on Earth. Approximately 160 miles long, 30 miles wide, over 1,000 feet deep in places. This lake has been sealed beneath the ice for an estimated 50 million years. Isolated, no contact with the surface, no sunlight. Constant pressure, constant cold, yet it's liquid, kept from freezing by the pressure of the ice above and geothermal heat from below. Researchers are fascinated by Lake Vostok. It's a unique ecosystem, completely isolated. If there's life in the lake, bacteria, microbes, it evolved in complete isolation for millions of years. Studying it could reveal new forms of life, new biochemistry, but drilling into the lake is controversial. Risk of contamination, risk of introducing surface bacteria into this pristine environment. The drilling has been done carefully, samples extracted, analysis ongoing. But here's what's interesting for our purposes. Lake Vostok proves that liquid water exists beneath Antarctic ice. And if there's one subglacial lake, there might be others. In fact, researchers have detected over 400 subglacial lakes in Antarctica using radar. Some of these lakes might be newer than Lake Vostok, formed during warmer periods, perhaps connected to the surface during the ice-free window thousands of years ago. If people lived on coastal Antarctica during that window, if they built structures near these lakes or near the coast, those structures would now be underwater, subglacial, preserved in the cold, inaccessible. Now, let's talk about Wilkes Land. In 2006, scientists analysing gravity anomaly data from satellites detected something unusual in Wilkes Land, a region in East Antarctica. A massive circular structure beneath the ice, over 300 miles in diameter. A gravity anomaly suggesting dense material. A specific formation. Further analysis suggested this might be an impact crater, an asteroid or comet impact. Dating is uncertain, but some estimates place it around 250 million years ago. The Permian-Triassic extinction event, the largest mass extinction in Earth's history. If this is an impact crater, it's larger than the Chicxulub crater in Mexico, the one that killed the dinosaurs. Much larger. What does this have to do with lost civilizations? Probably nothing. The impact is too old. but it demonstrates something important. There are massive geological features beneath Antarctic ice that we're only beginning to discover. Features invisible from the surface, features that require sophisticated technology to detect. Could there be other features? Other structures? Not geological, but artificial? Under 2 miles of ice, you could hide anything. Cities, monuments, entire civilizations, and we'd never know unless we drilled or used ground-penetrating radar at extremely high resolution, or waited for the ice to melt. Let's talk about the climate window more specifically. When was Antarctica last habitable? Not millions of years ago, but thousands. Some researchers propose that parts of coastal Antarctica were ice-free until relatively recently, perhaps as recently as 4,000 to 6,000 years ago. This is controversial. Most glaciologists believe that ice sheets have been stable much longer. But paleoclimate data isn't perfectly clear. There are gaps, uncertainties. If there was a window, if parts of Antarctica were accessible during the early Holocene, the period after the Ice Age, then people could have reached it. Maritime cultures, the same people who mapped coastlines, built megaliths, tracked stars, they could have sailed south, established settlements, lived there during the warm period. Then the climate shifted, the ice advanced, and they left, fleeing north, carrying with them maps, knowledge, memories of the southern land. Or they didn't leave, they stayed too long, and the ice came, and they were buried. Speculation. Pure speculation. There's no direct evidence of human habitation in Antarctica during this period, but absence of evidence isn't evidence of absence, especially when the evidence is buried under miles of ice. Picture this. It's 8,000 years ago. You're standing on a rocky beach. The water is cold but not frozen. Ice shelves loom in the distance, but here, at this sheltered bay, the summer is relatively mild. Penguins nest on the rocks. Seals bask in the weak sunlight. Your people have lived here for generations. You fish, you hunt seals, you build stone shelters against the wind, you watch the stars, the southern stars, constellations that never set. You track the seasons, the long summer days, the endless winter nights, and you notice something. The ice is advancing, slowly, year by year. The glaciers are growing. The summer melt is less each year. The winters are colder. You know what's coming. You've heard the stories. The elders remember when the bay was warmer, when there was less ice. The world is changing, and you make a decision. You load your boats. You say goodbye to the land. You sail north, toward warmer waters, toward lands that won't freeze, and you bring your knowledge, your maps, your star charts, your astronomical observations made from the unique vantage of the southern latitudes. You become teachers, refugees, survivors, or maybe you don't leave, maybe you stay, and the ice comes, and you're buried. Your structures, your maps, your knowledge, all frozen. Waiting, let these thoughts drift into the realm of sleep. Picture the continent, white, vast, silent, and beneath it, hidden the possibility. Maybe there's nothing, maybe it's just rock and ice. Maybe the maps are copied errors. Maybe the climate window never existed. Maybe humans never reached Antarctica before modern exploration. Or maybe there's something there, under the ice, waiting, preserved in the cold, cities, temples, libraries, evidence of a civilization that thrived when Antarctica was green. Evidence that would change everything we know about human history. 2 miles of ice, an entire continent, locked away. The largest remaining unexplored region on Earth. If the answer is anywhere, it's there, frozen, waiting, but we may never know. Drilling through 2 miles of ice is expensive, difficult, politically complicated. Antarctica is governed by international treaty. Scientific research is permitted. But large-scale excavation, searching for lost cities, that's not a priority, so the ice keeps its secrets. The continent sleeps, and we're left with tantalizing hints, maps that show coastlines, myths that describe southern lands, possibilities that can't be confirmed or denied. Sleep now. The ice is patient. It's been keeping secrets for thousands of years. It can keep them a little longer. Beneath the ice, the mystery waits, frozen in time, preserved, silent. Maybe someday the ice will melt. Maybe climate change will reveal what's beneath. Maybe future technology will peer through the ice with perfect clarity. Or maybe the secrets will remain buried, forever frozen, forever unknown. Antarctica, the missing piece. The final frontier. The frozen answer to questions we're only beginning to ask. Good night, explorers. The southern continent waits, silent, white, vast, and beneath it all, possibility. Picture yourself in a university lecture hall. You're a young archaeologist, eager, passionate. You've just completed your PhD. Your dissertation on conventional Egyptian chronology. You followed the accepted timeline, used the approved methodologies, cited the established authorities. You got the degree, you got the job. Assistant professor, tenure track. Your career is beginning, and then you read something, a paper, a book, an alternative theory about the age of the Sphinx, or the purpose of the pyramids, or the possibility of pre-Younger Dryas civilization. The evidence is interesting, compelling. Even, you start to wonder, start to question. What if the conventional timeline is incomplete? What if there's more to the story? So you mention it casually at a faculty meeting in a conversation with your department head. You suggest maybe this alternative theory deserves consideration, maybe further research, and you watch the temperature in the room drop. You see the glances, the concerned looks, the polite but firm dismissal. That's pseudo-archaeology, they say. That's not serious scholarship, that's fringe. If you want to be taken seriously, you'll focus on legitimate research. You understand the message. Pursue these ideas, and your career is over. No tenure, no grants, no publications in respected journals. You'll be labelled a crank. An outsider, someone who abandoned scientific rigour for sensationalism. So you stay quiet. You push the questions aside. You continue with conventional research. You play it safe, because that's how paradigms work. They protect themselves, not through conspiracy, not through secret meetings or deliberate suppression, but through institutional inertia, through career incentives, through the structure of academia itself. Let's talk about Thomas Kuhn. In 1962, philosopher of science Thomas Kuhn published a book, The Structure of Scientific Revolutions. In it, he described how science doesn't progress smoothly, doesn't move forward through gradual accumulation of knowledge. Instead, science operates within paradigms, frameworks of accepted theory, methodology, and interpretation. Most scientific work is what Kuhn called normal science, working within the paradigm, solving puzzles, filling in details, confirming what's already accepted. But sometimes anomalies accumulate. observations that don't fit the paradigm, results that contradict the accepted theory. At first, these anomalies are ignored, dismissed as errors, explained away. But if enough anomalies pile up, if the contradictions become too glaring to ignore, eventually the paradigm cracks. A scientific revolution occurs. The old framework is replaced with a new one that better explains the evidence. The shift from geocentrism to heliocentrism, from Newtonian physics to relativity, from static universe to Big Bang cosmology. These paradigm shifts are traumatic. The old guard resists. They've built careers on the old paradigm, published papers, written textbooks, trained students. Admitting the paradigm is wrong means admitting their life's work was built on shaky foundations, so they resist, not out of malice, not out of conspiracy, but out of human nature, out of cognitive investment, out of the difficulty of changing deeply held beliefs, and eventually they retire or die, and a new generation takes over, a generation that grew up with the new paradigm, that never invested in the old one, and the revolution becomes complete. Archaeology is no different. The current paradigm in archaeology is clear. Civilization began around 5,000 to 6,000 years ago in Mesopotamia, in Egypt, in the Indus Valley. Before that, humans were hunter-gatherers or early farmers. No large-scale organization, no monumental architecture, no advanced knowledge. The progression is linear, simple to complex, primitive to advanced. Stone Age to Bronze Age to Iron Age to classical civilization. This paradigm works, mostly. It explains most of the evidence, fits most of the data, allows for productive research. But there are anomalies. Göbekli Tepe. Built 11,600 years ago by people who supposedly had no civilization. Anomaly. The Sphinx water erosion, suggesting it's much older than conventional dating. Anomaly. The ancient maps showing Antarctica without ice. Anomaly. The precision of ancient stone cutting. Anomaly. The global flood myths correlating with real sea level rise. Anomaly. For years, mainstream archaeology dismissed these anomalies. Göbekli Tepe was explained as a special case, an exception, not evidence of widespread pre-agricultural civilization. The Sphinx erosion was attributed to other factors: groundwater, chemical weathering, not rainfall. The maps were dismissed as coincidence or artistic interpretation. The precision was explained as patient craftsmanship with primitive tools. The flood myths were explained as universal human experience with local flooding. All the anomalies were explained away, fitted into the existing paradigm, or ignored. But the anomalies keep accumulating, and some researchers outside the mainstream, often without academic positions, kept pointing them out, kept asking questions, kept suggesting alternatives. Graham Hancock, Robert Schoch, John Anthony West, researchers who looked at the evidence and said, maybe the timeline is wrong. Maybe there's an earlier chapter of human history we're missing, and the academic establishment labelled them pseudo-archaeologists, fringe theorists. Unscientific, are they right? Are these alternative researchers onto something, or are they seeing patterns that don't exist? Connecting dots that shouldn't be connected? That's the question, and it's not easy to answer. Because the alternative researchers aren't always careful. Sometimes they overreach. Sometimes they make claims that aren't supported by evidence. Sometimes they appeal to ancient aliens or mystical energy or other explanations that strain credulity. And that gives mainstream archaeology ammunition. See, this is pseudoscience. This is speculation. This isn't serious scholarship. But here's the problem. Dismissing all alternative theories because some are poorly argued means you might miss the legitimate questions, the real anomalies, the evidence that doesn't fit. Science progresses by questioning, by challenging assumptions, by following evidence even when it contradicts the accepted paradigm, and sometimes the fringe is right. Continental drift was fringe once. Alfred Wegener proposed in 1912 that continents move, that South America and Africa were once connected. The geological establishment rejected it, ridiculed it, called it impossible. For decades, continental drift was considered pseudo-science. Wegener died in 1930. His theory dismissed. Then, in the 1960s, evidence accumulated. Seafloor spreading, magnetic striping, plate tectonics, and suddenly continental drift was not only accepted but foundational to modern geology. Wegener was right. The establishment was wrong. The paradigm shifted. The same thing happened with meteors. In the 18th century, scientists dismissed reports of rocks falling from the sky. Impossible, they said. Peasant superstition. Rocks don't fall from the sky, until enough evidence accumulated. Meteorites were collected, analysed, and scientists had to admit, yes, rocks do fall from the sky. The paradigm shifted. Helicobacter pylori and stomach ulcers. For decades, the medical establishment believed ulcers were caused by stress and diet. Then Barry Marshall and Robin Warren proposed that ulcers were caused by bacteria. The establishment rejected it. Bacteria can't survive in stomach acid. Marshall was so confident he infected himself with H. pylori, developed gastritis, cured it with antibiotics, proved his point. Eventually, the paradigm shifted. Marshall and Warren won the Nobel Prize. The fringe was right. The establishment was wrong. So when alternative archaeologists propose that civilization is older than we think, that there might be evidence of advanced cultures before 10,000 BC, are they wrong? Or are they the next Wegener? The next Marshall? We don't know yet. The evidence is incomplete. The anomalies are suggestive but not conclusive. But what's clear is that mainstream archaeology is resistant to the idea. Resistant in ways that go beyond scientific skepticism. Let's talk about specific examples, the Smithsonian controversies. Over the years, various reports have suggested that the Smithsonian Institution suppressed evidence of anomalous archaeological finds in North America, giant skeletons, unusual artifacts, finds that didn't fit the conventional narrative of Native American prehistory. Are these reports true? It's hard to say. The evidence is largely anecdotal. Newspaper clippings from the 19th and early 20th centuries reporting giant skeletons found in burial mounds. Then, nothing. The skeletons disappeared, never formally studied, never displayed. The Smithsonian denies suppression, claims these reports were exaggerations or hoaxes, claims the skeletons, if they existed, were normal human remains misidentified or embellished by sensationalist journalists. Maybe, or maybe there's something to the reports. Maybe finds that didn't fit the narrative were quietly shelved, not destroyed, not deliberately hidden, just not prioritized, not published, not studied, not conspiracy. Just institutional bias. A preference for evidence that confirms the paradigm and a disinterest in evidence that challenges it. Then there's the issue of dating disputes. Carbon-14 dating is the standard method for dating organic materials up to about 50,000 years old. It's reliable. Mostly, but it has limitations. Contamination can affect results. If modern carbon gets into an ancient sample, it will appear younger than it is. If ancient carbon leaches out, it might appear older. And there are calibration issues. The amount of C14 in the atmosphere varies over time. Calibration curves correct for this, but the curves are based on assumptions, based on correlating C14 dates with other dating methods. When C14 dates contradict the accepted chronology, they're often dismissed as contaminated, as errors, as outliers. But what if some of those dates are correct? What if some organic materials associated with ancient structures are genuinely older than the paradigm allows? The paradigm doesn't permit it, so the dates are rejected and research moves on. This isn't necessarily suppression, it's quality control. Ensuring accuracy, but it can become circular. Dates that fit the paradigm are accepted. Dates that don't are rejected, and the paradigm is never challenged. Now let's talk about career risk. Robert Schoch is a geologist. PhD from Yale, professor at Boston University, legitimate credentials, respected in his field. In the early 1990s, he examined the Sphinx in Egypt, applied geological analysis to the erosion patterns, concluded that the erosion was caused by rainfall, heavy rainfall. The kind of rainfall that hasn't occurred in Egypt since before 10,000 BC. His conclusion, the Sphinx is much older than conventional Egyptology claims. He published his findings, presented them at conferences, and was met with resistance. Not from geologists. Many geologists found his analysis sound, but from Egyptologists. The Egyptologists said, impossible. The Sphinx was built by Khafra around 2500 BC. That's established. That's the accepted chronology. Your geological analysis must be wrong. Schoch stood by his work, and his career suffered. He wasn't invited to certain conferences, wasn't included in certain projects, was labelled a fringe theorist, not blacklisted, not silenced, but marginalised, a subtle pressure. A signal to other academics, question the paradigm and face consequences. John Anthony West, an independent Egyptologist. No PhD, no university position, but deeply knowledgeable. He spent decades studying ancient Egypt. He collaborated with Schoch on the Sphinx erosion research. West was never going to have an academic career. He was already outside the system. So he had freedom to ask questions, to challenge assumptions, to pursue unconventional ideas. But he was also dismissed. His work, no matter how careful, was labelled pseudo-archaeology because he didn't have the credentials, because he didn't publish in peer-reviewed journals, because he was outside the club. Graham Hancock, journalist, author, researcher. He's written extensively about lost civilizations, about the possibility of advanced cultures before the accepted timeline. His books are bestsellers, millions of copies sold, popular, influential, and absolutely despised by mainstream archaeology. Hancock is the boogeyman. The example of what serious scholars should not be. His work is dismissed, his theories rejected, his name invoked as a warning. Some of the criticism is fair. Hancock makes speculative leaps, connects evidence in ways that aren't always rigorous, sometimes appeals to explanations that are hard to test, but some of the criticism is simply paradigm protection. Hancock questions the timeline, questions the narrative, questions the authority of mainstream archaeology. And for that, he's rejected. Interestingly, Hancock has been vindicated in one significant way. For years, he argued that Göbekli Tepe was evidence of advanced pre-agricultural culture. That civilization was older than mainstream archaeology acknowledged, and mainstream archaeology said, no, impossible. Hunter-gatherers can't build monumental architecture. Then Göbekli Tepe was excavated, fully analysed, dated. And it was exactly what Hancock said it was, a massive, sophisticated structure built by pre-agricultural peoples 11,600 years ago. The paradigm had to adjust, had to acknowledge that monumental architecture predates agriculture. That the timeline was incomplete. Hancock was right about that. Maybe he's right about other things too. But the academic establishment still dismisses him, because acknowledging he was right would mean acknowledging the paradigm can be wrong. And paradigms don't like to admit error. Now, let's be clear. Not all resistance to alternative theories is unjustified. Not all fringe ideas deserve acceptance. Science requires standards, requires evidence, requires reproducibility and peer review, requires skepticism, and many alternative archaeology theories don't meet those standards. They rely on cherry-picked evidence, ignore contradictory data, make claims that can't be tested. Ancient aliens built the pyramids? There's no evidence for that. None. It's speculation based on the assumption that ancient humans weren't capable of building them. That's not a theory. That's a failure of imagination. Crystal skulls with mystical powers. Most crystal skulls have been shown to be modern forgeries. The famous Mitchell-Hedges skull was likely made in the 19th century using rotary tools. Atlantis was a high-tech civilization destroyed by a war with aliens. Pure fantasy. Not supported by any archaeological evidence, so skepticism is warranted. Dismissing fringe theories that lack evidence is appropriate. But there's a difference between healthy skepticism and paradigm rigidity. Between requiring evidence and refusing to look at evidence, between maintaining standards and protecting orthodoxy. And right now, archaeology is in a delicate position. The paradigm is being challenged, not by pseudoscience, but by legitimate discoveries, by Göbekli Tepe, by underwater structures, by ancient maps, by genetic data showing unexpected population movements. The anomalies are piling up, and a new generation of archaeologists is emerging. A generation more open to revising the timeline, more willing to consider that the story of human civilization is more complex than previously thought. The paradigm is shifting, slowly, gradually, but it's happening. Universities are offering courses on alternative archaeology, not to promote it, but to critically examine it, to teach students how to evaluate evidence, how to distinguish legitimate questions from pseudoscience. New technologies, LiDAR, ground-penetrating radar, satellite imagery, are revealing hidden sites. Cities under jungle canopies, structures underwater, features that were invisible until now. And each discovery adds nuance to the story, shows that human capability and organisation emerged earlier than we thought, that the timeline of civilization is longer and more complex. Let these thoughts settle. The resistance to new ideas isn't unique to archaeology. It's how paradigms work, how human institutions work, But paradigms do shift, eventually, when the evidence becomes overwhelming, when the old guard retires, when a new generation takes over. We're living through that shift now. The timeline is being revised, the story is being rewritten, slowly, carefully, with proper evidence. Maybe there was a civilization before the flood. Maybe Antarctica holds secrets under its ice. Maybe the maps and myths preserve real memories, or maybe not. Maybe the conventional timeline is mostly correct. Maybe the anomalies will be explained within the existing paradigm. Either way, the questions are legitimate. The evidence deserves examination, and the paradigm should be flexible enough to adjust if the evidence demands it. That's how science is supposed to work. That's how we get closer to truth. Sleep now. The paradigm shifts slowly. Like continental drift, imperceptible day to day, but over time the landscape changes. Truth doesn't need permission, it just needs time, and maybe the ice to melt. Good night, questioners. Your questions matter. The year is 2018, Guatemala. The dense jungle of the Petén region. For centuries, the Maya civilization has been hidden here. Temples swallowed by vegetation. Cities lost beneath the canopy. Archaeologists have been working in the region for over 100 years, excavating, mapping, discovering. But they've only scratched the surface. The jungle is too thick, too vast. You can walk past a pyramid and never know it's there, hidden under soil and roots and centuries of growth. Then a team of archaeologists tries something new. They use LiDAR, light detection and ranging. Aircraft equipped with laser scanners fly over the jungle. The lasers penetrate the canopy, bounce off the ground beneath, create a detailed three-dimensional map of the terrain. When the researchers process the data, they see something extraordinary. The jungle isn't hiding a few scattered ruins, it's hiding an entire civilization, thousands of structures, cities, roads, agricultural terraces, defensive fortifications, over 60,000 previously unknown structures. The Maya civilization was far larger than anyone realized, far more complex, more populous, more sophisticated, all hidden beneath the jungle. Invisible from the ground, invisible from satellite photos, but revealed by technology that can see through the canopy. One flight, a few weeks of data collection, and our understanding of Maya civilization transforms. This is happening now, all over the world. New technologies are revealing hidden history, sites that were always there but invisible, inaccessible, unknown, and as they're revealed, we're forced to revise our assumptions, to acknowledge that human history is deeper, more complex, more extensive than we thought. LiDAR has been deployed in Cambodia, over Angkor Wat and the surrounding region. The temples were known, studied for decades, but the LiDAR revealed something more, an entire urban landscape. Networks of roads, canals, neighbourhoods. The temples weren't isolated monuments, they were the centre of a sprawling medieval metropolis, one of the largest cities in the world at its peak. LiDAR in Central America continues to find new sites, lost cities emerging from the jungle, week after week, month after month. Each discovery adding detail to the story of pre-Columbian civilization. LiDAR in England, revealing ancient earthworks, henges, burial mounds, settlement patterns, features worn down by millennia of agriculture, but still detectable from the air. This technology is changing archaeology. making the invisible visible, and it's only the beginning. Satellite archaeology. Using high-resolution satellite imagery and multispectral analysis to detect buried structures, differences in vegetation, soil moisture, temperature. These variations can indicate walls, foundations, roads beneath the surface. Sarah Parcak, a pioneer in satellite archaeology, has used this technique to discover thousands of sites in Egypt, Peru, and elsewhere. Ancient settlements, pyramids, entire cities, detected from space. The technology is becoming more sophisticated. Machine learning algorithms can analyze satellite data, identifying patterns that indicate archaeological sites, scanning vast regions in days, finding sites that would take human archaeologists decades to discover on foot. But there's a race happening, a race against time, against climate change, against development, against looting. Climate change is transforming the planet. And in some ways, it's revealing the past. Glaciers are melting in the Alps, in the Andes, in Alaska. Glaciers that have existed for thousands of years are retreating, and as they melt, they expose what they've preserved. In 1991, hikers in the Italian Alps discovered a body emerging from melting ice, Ötzi the Iceman, a man who died around 3,300 BC. Frozen, preserved, perfectly preserved. His clothing, his tools, his last meal still in his stomach. Ötzi provided unprecedented insight into Copper Age life, what people wore, what they ate, how they travelled, medical conditions, evidence of violence. A complete picture of one individual from 5,000 years ago. And as glaciers continue to melt, more discoveries emerge. Artifacts, remains, evidence of ancient human activity at high altitudes. Mountain passes that were used thousands of years ago. Trade routes, hunting grounds, sacred sites. The melting is tragic. Glaciers are climate regulators, water reserves, ecosystems. Losing them is a disaster. But the silver lining, the only silver lining, is that they're revealing history, giving us back pieces of the past that were locked away. In Scandinavia, melting ice patches reveal Viking artifacts, arrows, textiles, evidence of medieval hunting practices. In the Arctic, melting permafrost exposes mammoth remains, ancient settlements, evidence of how humans lived during the Ice Age. In the Himalayas, retreating glaciers reveal those ancient forests. Trees that grew thousands of years ago when the climate was warmer, preserved in ice, now emerging, and researchers are racing to document these finds before they're lost, because once exposed, organic materials deteriorate rapidly. Ice preserves. Air and bacteria destroy. What the ice held for millennia can decay in years once exposed. The race is on. To find, to document, to preserve. But climate change isn't just revealing the past, it's threatening it. Rising sea levels. We discussed how sea levels rose catastrophically at the end of the Ice Age. Drowning coastlands, submerging settlements. It's happening again, more slowly this time, but inexorably. Sea levels are rising. Coastal areas are flooding, and coastal archaeological sites are endangered. Venice. The city is sinking, built on wooden pilings driven into the mud of the Venetian lagoon. As sea levels rise and the land subsides, the city floods more frequently. Acqua alta, high water, once rare, now routine. The city is installing barriers, trying to hold back the sea. But long-term, Venice is in trouble. Alexandria, the ancient city on Egypt's Mediterranean coast. Parts of the ancient city are already underwater, submerged when the coastline sank following earthquakes, and as sea levels rise, more of the coastal archaeology is threatened. Coastal sites worldwide, in Bangladesh, in the Pacific Islands, in Florida, in the Netherlands, are at risk. Archaeological sites that survived thousands of years now face inundation, erosion, destruction. And then there's development. Human population is expanding, cities are growing, infrastructure is being built, and archaeological sites are in the way. In some countries, regulations protect archaeological sites. Development must pause when ruins are discovered. Excavations are conducted. The site is documented or preserved. But in other places, the regulations are weak or ignored, and sites are bulldozed, destroyed, lost forever. Looting is another threat, particularly in regions with weak governance, war zones, remote areas. Archaeological sites are looted for artifacts that can be sold on the black market. Sculptures, pottery, jewellery, ripped from context, smuggled, sold to private collectors. Each looted site loses its story. Artifacts removed from context can't tell us where they came from, what they were used for, what they mean. They become curiosities, decorations, investments, but their scientific value is destroyed. So archaeologists are racing to document sites before they're lost. Before the glaciers melt completely, before the seas rise, before development destroys them, before looters steal them. And the new technologies, LiDAR, satellite imagery, ground-penetrating radar, are accelerating the race, finding sites faster than ever, giving archaeology a chance to document before it's too late. But here's the question: what are we learning? What do these discoveries tell us? They tell us that human civilization is older, more widespread, more sophisticated than we thought. That the neat timeline of progress, simple to complex, primitive to advanced, is too simple. That humans have been building, organizing, creating for far longer than recorded history suggests. And that raises a deeper question. What can we learn from these lost civilizations? What do they teach us? One lesson: resilience. The civilizations we're discovering didn't survive. They collapsed, abandoned their cities, scattered, disappeared from the historical record, but they survived in another sense. Their descendants are still here. The Maya didn't vanish. Millions of Maya people live in Central America today, speaking Mayan languages, maintaining traditions. The civilization transformed, adapted, endured in a different form. The same is true of other collapsed civilizations. The ancestral Puebloans abandoned their great houses in Chaco Canyon. But their descendants, the modern Pueblo peoples, continue their traditions. The Indus Valley civilization declined. Cities were abandoned, but the people didn't disappear. They dispersed, merged with other populations, contributed to the genetic and cultural mix of South Asia. Collapse doesn't mean extinction, it means transformation, and the survivors carry forward knowledge, traditions, genes. So what caused the collapses? What can we learn to avoid similar fates? The Maya collapse is instructive. At their peak, the Maya built massive cities, supported dense populations, cleared forests for agriculture, terraced hillsides, built reservoirs. But they pushed the environment too hard. Deforestation led to soil erosion. Water management became critical. When drought came, and paleoclimate data shows severe droughts in the 9th century AD, the system couldn't cope. Crops failed. Water ran short. Cities were abandoned, not everywhere, not all at once. But the classic Maya civilization contracted, transformed. The great cities fell silent. The lesson. Environmental limits matter. Sustainability matters. Pushing a system too hard, ignoring warning signs, can lead to collapse. The ancestral Puebloans at Chaco Canyon. They built an impressive civilization in a harsh environment, the high desert of New Mexico. Limited rainfall, but they managed it. Built great houses, created trade networks, thrived for centuries. Then the climate shifted. Drought, extended drought, 50 years of below average rainfall. The system couldn't sustain the population. People left, moved to areas with more reliable water. The great houses were abandoned. Again, the lesson. Climate changes, sometimes slowly, sometimes abruptly. And civilizations that can't adapt collapse. The Western Roman Empire, overstretched. Politically fragmented, economically strained, facing pressures from migrating peoples, a complex system under stress. When key parts failed, military defeats, economic disruption, political instability, the whole system unraveled. The lesson: complexity is fragile. Interconnected systems can collapse rapidly when key nodes fail. Redundancy and flexibility matter. These aren't abstract historical lessons. They're relevant now. Today, we're facing environmental pressures, climate change, resource depletion, ecosystem stress. The same pressures that contributed to past collapses. We're facing social and political fragmentation, polarization, declining trust in institutions, economic inequality, the same stresses that weakened past civilizations. We're facing complexity, global supply chains, interconnected financial systems, technological dependencies, the same fragility that can lead to cascading failures. Are we headed for collapse? Not necessarily. We have advantages past civilizations didn't: technology, science, global communication, the ability to learn from history. But we also have vulnerabilities. They didn't: nuclear weapons, biological threats, cyber vulnerabilities, the potential for catastrophe on a scale no ancient civilization faced. The question is, will we learn? Will we adapt? Will we recognize the warning signs and change course? Or will we ignore the lessons until it's too late? The ancient civilizations are teachers, not through their successes, but through their failures. They show us what happens when systems are pushed too hard, when environmental limits are exceeded, when complexity becomes fragility. And maybe, if we listen, we can avoid their fate. Now let's talk about lost knowledge. What technologies or techniques have we lost that might be valuable today? Roman concrete, self-healing, more durable than modern concrete. Imagine infrastructure that repairs itself, roads that last centuries, buildings that withstand earthquakes and weather without maintenance. We're starting to understand the chemistry, starting to recreate it. Maybe soon we'll build with it again. Damascus steel, carbon nanotubes at the molecular level, created without understanding the science but through careful process. Imagine materials engineered at the nanoscale using traditional methods, sustainable, low-tech, but producing high-tech results. Ancient agricultural techniques. The Maya built sophisticated water management systems, terraces that prevented erosion, polyculture that maintains soil fertility. The ancestral Puebloans practiced dry farming in the desert. Modern industrial agriculture is productive but degrades soil, requires massive inputs of water and fertilizer. Maybe ancient techniques, adapted with modern knowledge, could create more sustainable systems. Traditional ecological knowledge. Indigenous peoples worldwide develop deep understanding of local ecosystems. Which plants are edible, medicinal, useful? How to manage forests, grasslands, fisheries sustainably. Much of this knowledge is being lost as languages and cultures disappear. But it's valuable, maybe more valuable than we realise. So there's a race to preserve this too. Linguists recording endangered languages, anthropologists documenting traditional practices before the last speakers die, before the knowledge is lost, because once lost, it's gone. You can't recreate it easily. It took generations to develop. Trial and error, observation, experience, and if it's not recorded, it vanishes. And finally, let's talk about Antarctica, the race happening there. Multiple nations have claims on Antarctic territory: Argentina, Chile, Australia, New Zealand, Norway, France, the United Kingdom. The claims overlap. Conflict is potential, but the Antarctic Treaty, signed in 1959, put territorial claims on hold. Antarctica is designated for peaceful purposes, scientific research, international cooperation. No military activity, no nuclear testing, no mineral exploitation. The treaty has held for over 60 years, but it's not permanent. It can be renegotiated. And as resources become scarcer, as minerals, oil, fresh water become more valuable, the temptation to exploit Antarctica grows. And there's another race: scientific research, understanding Antarctica's ice sheets, how fast they're melting, how much sea level rise they'll contribute. This matters globally. Billions of people live in coastal areas. If Antarctic ice melts significantly, coastlines will be redrawn, cities will flood. The consequences are profound, so nations are investing in Antarctic research, not just for scientific knowledge, but for strategic reasons. Understanding the future, positioning for influence if the treaty regime changes. And beneath it all, the mystery remains. What's under the ice? Are there secrets buried there? Lost civilizations? Ancient ruins? We don't know, and we may never know unless the ice melts. But if it does melt, if climate change proceeds unchecked, we'll lose the ice archives, the ice cores that preserve climate history going back hundreds of thousands of years. That evidence will be gone. Another race. To extract ice cores. To preserve the data. Before the ice melts and the archive is destroyed, so many races. Against time, against climate change, against looting and development and neglect. To find, to document, to preserve. To understand before it's too late. Let these thoughts settle. The past is fragile, more fragile than we realize. It can be lost, destroyed, forgotten, but it's also resilient, preserved in ice, in jungle, in ocean sediments, waiting to be found, waiting to tell its story. And the technologies we're developing, LiDAR, satellite archaeology, ice-penetrating radar, give us a chance to recover the past, to learn its lessons, to preserve its knowledge, before the glaciers melt completely, before the seas rise, before the last speakers of endangered languages die. We're living in a unique moment, A window of time when the past is being revealed faster than ever, when technology lets us see what was invisible, when climate change exposes what was frozen. But it's also a moment when the past is being lost, eroded, looted, destroyed. The race is on, and we're all part of it. Every discovery adds to the story. Every preserved site saves knowledge. Every documented tradition keeps memory alive. The ancients tried to warn us, built monuments to survive millennia, encoded knowledge in myths, aligned structures to the stars. They didn't have computers, didn't have satellites, but they survived what we haven't faced yet. Maybe we should listen to the stones, learn from the collapses. Remember the resilience, because the cycles continue. The earth changes, the climate shifts, and civilizations rise and fall, but knowledge endures if we preserve it, if we remember. Sleep now. Tomorrow the race continues, the search for the past, the preparation for the future. They're not separate, they're connected. The past teaches, the future waits, and we stand between them. Good night, seekers. The past is closer than you think. Picture yourself descending again, through blue water, off the coast of Japan, the same dive we began with, the sunlight filtering down, your breathing slow, rhythmic, the regulator hissing softly, and there below you, emerging from the shadows, those impossible angles, those perfect terraces, Yonaguni, the structure that shouldn't exist. You've journeyed far since that first descent. Not in distance, but in time, in understanding, in questions. You've stood before the megaliths of Göbekli Tepe, touchstones carved 11,600 years ago by people who supposedly had no civilization. Felt the precision of cuts that challenge our assumptions about what ancient peoples could achieve. You've looked up at Orion's belt and seen 3 pyramids positioned on Earth to mirror 3 stars in the sky. Watched the winter solstice sun illuminate the chamber at Newgrange exactly as it did 5,000 years ago. Trace the alignments that connect monuments to celestial events across millennia. You've heard the flood stories, from Sumer to the Americas, from India to Scandinavia. Over 270 cultures remembering water, drowning, survival. The same story told in different words, the same memory preserved through thousands of years. You've examined the maps. Piri Reis showing coastlines that shouldn't have been known. Orontius Phineus depicting Antarctica as 2 islands separated by water, exactly as it exists beneath the ice. Evidence of surveying, of navigation, of knowledge that predates our accepted timeline. You've held in your mind's eye the Damascus blade with its molecular perfection, the Baghdad battery generating electricity 2,000 years before Volta, the Roman concrete healing itself after centuries underwater, evidence that progress isn't always linear. That knowledge can be lost as easily as gained. You've seen the genetic whispers, the Denisovan DNA in your cells speaking of encounters with human cousins we knew nothing about until a decade ago, the bottlenecks showing how close we came to extinction, the markers suggesting journeys across oceans we thought were uncrossed. You've traced the linguistic echoes, the Basque language standing alone, unconnected to any family, speaking of deeper time, the shared words, the common symbols, the similar stories appearing in cultures separated by oceans. You've measured the precision, granite vases symmetrical to 1,000th of an inch, drill holes suggesting feed rates impossible with copper tools, polygonal masonry fitted without mortar so tightly that water can't penetrate. Evidence of capability we struggle to explain. You've studied the alignments, Giza mirroring Orion, Stonehenge framing the solstice sun, Angkor Wat encoding star positions from 10,500 BC, monuments positioned not randomly, but intentionally, marking celestial patterns, preserving astronomical knowledge. You've understood the catastrophe cycle. The myths describing ages of the world destroyed by fire, ice, flood. The geological evidence of the Younger Dryas impact. The rapid climate shifts recorded in ice cores. The patterns suggesting Earth experiences periodic cataclysm. And the possibility that the ancients knew this, remembered this, tried to warn us. You've contemplated Antarctica, the continent-sized mystery beneath 2 miles of ice. The maps showing it without ice. The possibility, remote but real, that something waits there, frozen, preserved, hidden. You've seen the resistance, the paradigm protecting itself, the career risks faced by those who question, but also the slow shift, the gradual opening, the acknowledgement that the timeline is longer, more complex than we thought, and you've recognized the urgency. The race against melting glaciers, rise in seas, development, looting, the window of time we have to discover, document, preserve before the evidence is lost. So much explored, so many questions raised, so much evidence examined, and yet you surface from the dive. Break through the water, remove your regulator, breathe the air. Look back down into the blue depths where Yonaguni waits. And you realize you don't have answers. You have mysteries. Beautiful, compelling, enduring mysteries. Is Yonaguni natural or artificial? We don't know for certain. Geologists disagree. The evidence allows both interpretations, and perhaps that's okay. Did an advanced civilization exist before the Ice Age floods? Maybe. The evidence is suggestive. The maps, the myths, the monuments, they all point towards something, but we can't prove it. Not yet. Not with the certainty science demands. Is there a catastrophe cycle? Are we approaching another one? The patterns are there. The myths are consistent. The geological evidence is real, but correlation isn't causation. Patterns can be coincidence. We don't know. What's under the Antarctic ice? We won't know until we look, until the ice melts, or we drill, or radar technology improves. Until then, it's speculation, possibility, mystery, and maybe that's enough. Maybe we don't need definitive answers. Maybe the mystery itself is valuable, the questions more important than the conclusions, because mystery inspires, wonder motivates, the unknown beckons us forward, makes us curious, makes us search, makes us question our assumptions and examine our beliefs. If we knew everything, if all questions were answered, if the past held no secrets, would we still care? Would we still look? Would we still try to understand? The stones at Göbekli Tepe don't need our understanding to have meaning. They exist. They endure. They speak to those willing to listen. Whether we interpret them correctly or not, they remain. Patient, eternal, waiting. The stars continue their patterns above the pyramids. Whether Bauval's correlation theory is exactly right or not, whether the alignments are intentional or coincidental, Orion still rises, still crosses the sky, still marks time as it has for billions of years. The flood myths persist, whether they're literal memories of the younger Dryas or metaphorical representations of transformation and renewal. They've survived, carried through generations, preserved, retold, meaningful. The ice covers Antarctica, whether cities lie beneath or just rock. Whether maps show truth or imagination, the continent waits, silent, white, holding its secrets close. And we continue searching, continue questioning, continue wondering, because that's what humans do. We're the species that looks at the horizon and asks, what's beyond? We're the ones who examine the night sky and wonder what's out there. We're the creatures who find ancient stones and ask, who built this? Why? That curiosity, that relentless need to know, is part of what makes us human. It drove the first humans out of Africa, drove them across continents, drove them to cross oceans in fragile boats, drove them to build monuments that would outlast their civilizations. And it drives us still to excavate, to analyze, to question, to preserve. The ancient peoples who built Göbekli Tepe, who carved the Sphinx, who aligned Stonehenge to the solstice sun, they didn't build for themselves alone. They built for us, for the future, for the descendants who would come after. They built in stone because stone endures. They aligned to the stars because stars are eternal. They encoded knowledge in myths because stories survive when buildings fall. They were sending a message forward through time, not a clear message. Not an obvious one, but a message nonetheless. And the message is this: we were here, we knew things, we built things, we survived catastrophe, we persevered. We are your ancestors. Don't forget us. Don't forget what we learned. Don't forget to watch the stars. Don't forget to respect the earth. Don't forget that cycles repeat. Don't forget to prepare. Don't forget to remember. Whether we fully understand the message or not, whether we interpret it correctly or not, the effort to send it matters. The monuments standing for millennia matter. The myths preserved through generations matter. They're proof that humans have always tried to transcend their moment, to reach beyond their lifespans, to connect with the distant future, to leave something that endures. And we're doing the same, building monuments in our own way. Not in stone, but in data. Satellites, digital archives, seed vaults, cultural preservation projects, trying to leave something for those who come after, trying to survive our own catastrophe, climate change, environmental degradation, political instability, the challenges we face now. And maybe the ancients have something to teach us about that, about resilience, about survival, about adapting when the world changes, about preserving what matters most. They didn't have our technology, but they had wisdom, accumulated over generations, hard-won through experience, and some of that wisdom survived, in the stones, in the stars, in the stories. If we listen, if we remember, if we humble ourselves enough to learn from those who came before. Let these final thoughts drift now. Let them settle into the quiet spaces of your mind as sleep approaches. The diver surfaces, removes the mask, looks back at the blue water hiding Yonaguni beneath, and feels not frustration at the mystery, but gratitude for it. Gratitude that there are still questions, still wonders, still unknowns. The world is larger than we think, deeper, more mysterious, more ancient, more connected, and we're part of that story. Part of the long chain stretching from the first humans who looked up at the stars and wondered, to the future humans who will uncover what we leave behind. We inherit from the past, we contribute to the future. We stand in the middle, asking questions, seeking answers, preserving what we can. The stones will outlast us, as they outlasted those who built them. Göbekli Tepe will stand long after we're gone. The pyramids will endure. Stonehenge will mark the solstice sun for centuries more, and maybe that's comforting, the knowledge that some things persist. That we're part of something larger than ourselves, something that transcends individual lives, individual civilizations, individual ages. Time flows, the earth turns, the stars wheel overhead, and the monuments stand, pointing, marking, remembering. Sleep now. The mysteries will be here when you wake. The stones will still stand. The stars will still turn. The questions will still wait. And that's okay. That's good. That's as it should be. Because we're not meant to know everything. We're meant to wonder, to search, to question, to marvel at the unknown. The ancients understood this. They built monuments full of mystery, encoded knowledge in ways we're still trying to decipher, left questions that might never be fully answered, not out of cruelty. Not to frustrate us, but because mystery is sacred, wonder is valuable. The search itself matters more than the destination, so rest easy. The past is patient. The stones have waited thousands of years. They can wait through one more night. The water is calm now. The dive is over. The journey through secret civilization theory complete. Not with answers, but with deeper questions, better questions, more beautiful questions. And tomorrow, when you wake, the world will still be ancient and mysterious and full of wonders we're only beginning to glimpse. The diver sleeps, the stones sleep, the stars turn slowly above, the ice holds its secrets. The myths whisper in the darkness, and somewhere in the deep time between now and then, between what was and what might be, the answer waits, patient, eternal, encoded in stone and stars and stories. We just have to remember how to read it. Good night, wanderers. Good night, questioners. Good night, descendants of survivors and builders and dreamers. The stones will keep watch. They've been doing it for millennia. They can do it one more night. Sleep well. The mysteries endure. The search continues. The wonder remains. And in the morning, when you wake, maybe you'll look at the ancient world a little differently, with more respect, more curiosity, more wonder, because it's not primitive, it's not simple, it's not fully understood, it's secret, it's sophisticated, it's waiting. Good night.